Welcome to the Terminal Multiverse, the second module of Intuitive DevOps for You course. So here we will explore about the terminal verse. Most importantly, we will explore about the Linux. So the following topics we are going to look into it in this session, starting with Linux shells, getting to the shell, basic bash shell commands, more bash shell commands, understanding the shell, using Linux environment variables, understanding Linux file permissions, managing file systems, installing software, working with editors. So let's begin with Know Your Linux. Before you can dive into working with the Linux command line and shells, you should first understand what Linux is, where it has come from, and how it works. So basically, this slide walks you through the what a Linux is and explains where the shell and command line fit in in the overall Linux picture. Wading through the world of Linux for the first time can be a tricky experience, though this chapter takes some of the mystery out of the Linux system before you start working on commands and then bash scripts. So, other than computer hardware, a Linux system primarily consists of four important parts. The first one is Linux kernel, and the second one is the GNU utilities, and the third one is a graphical desktop environment. It's a window management software. I will explain you in detail in coming videos. And the fourth one is application software. So these are the core components of any Linux system. So each of these parts has a specific job in the Linux system. No part is very useful by itself. So for now, we will look into the computer hardware. A computer hardware is a physical device of computers that we can see and touch. For example, monitor, CPU, mouse, joystick, etc. Using these devices, we can control computer operations like input and output. So these hardware components are further divided into the following categories, which are input devices, output devices, storage devices, internal components. So let's begin with input devices first. Input devices are uh, those devices with the help of which the user interacts with the computer, or in other words, with the help of input devices the user enters the data or information into the computer. This information or data is accepted by the input devices and converted into a computer acceptable format, which is further sent to the computer system for processing. And the second important devices are output devices. These are the devices that are used to display the output of any task given to the computer in human readable form. Now we discuss some output devices in brief. So you what presently at this moment you are watching my tutorial in YouTube through a laptop or maybe a PC personal computer. So the output is coming through monitor. So monitor is the main output device. It is also called VDU, Visual Display Unit, and it looks like a TV screen. The monitor displays the information from the computer. It is used to display text, video, images, etc. You are streaming my video presently through this output device. And second one is printer. Printer is also an output device that transfers data from computer in a printed format by using the text or images on paper. So these are both colored and black and white printer. So further, there are also different types of printers like laser printers, dot matrix printers, and inkjet printers. And the third one is plotter. Plotter, it is similar to the printer, but plotters are larger in size. A plotter is used to generate large drawings, architectural blueprints, etc. on paper, and these are high quality images and drawings and large in size. And the fourth one is speakers. Of course, you're listening my voice from the speakers, the output of the speakers. It is a very common output device and it gives sound as an output. So it is generally used to play music or anything having sound or listening to my videos. Okay, then we have storage devices. There are some devices that are used for storage purposes and are known as secondary storage devices. Some of them were discussed below. One is CD. It's a compact disc at this moment, present day. These are almost not in use, but still will understand what is CD. A CD is a circular disc that you can see on your screen, uh, circular in shape and made up of thin plated glass and plastic polycarbonate material. It has a storage capacity of 600 MB to 700 MB data. It has a standard size of 12 centimeter with a hole in the center of about 1.5 centimeter and 1.2 millimeter in thickness. There are basically three types of CDs, and that's enough delving into the CD. Let's move on to the another one, that is hard disk. The next one is hard disk. And hard disk is a non-volatile storage device that uses its read-write heads to store digital data on the magnetic surface of a rigid plate. It is generally 3.5 inches in size for desktops and 2.5 inches in size for laptops. Before I would like to also know that I have uploaded one more course, that is IPython for you, that's intuitive Python for you. In that I have clearly explained how this magnetic forces are used, how this magnetic concept is used in storing the data and old hard disks. So you can just get back to that course and then watch to get the detailed description of how this hard disk works. And before that, and to continue with our present course, then we have internal hard disk, internal cartridges, etc., and hard disk packs. These are the ones. And finally, the most important components of your computer hardware is internal components. Internal components, these are very important hard devices known as the internal components. So the most important one is CPU, Central Processing Unit. Central Processing Unit is also known as the heart of the computer. It consists of three units in general known as the control unit, arithmetic logical unit, and the memory unit. So below is like the next important component of internal components is motherboard. Motherboard is the main circuit board inside a computer, and it contains most of the electronic components together. All components of the computer are directly or indirectly connected to the motherboard. So it includes RAM slots, controllers, system chip, system chipset, etc. And the next thing is RAM, random access memory. It is also known as temporary or volatile memory. It holds the program and data which are currently in process of processing. All the data is erased as soon as the computer is turned off or in case of power failure. So data stored in the memory can be changed. Basically, there are two types of RAM. One is SRM or SRAM, static RAM. Other one is DRAM, dynamic RAM. Then what is the difference? SRAM, that static RAM, consists of flip flop using a transistor or MOSFET transistor. It's the fast and has less access time. In refreshing circuits are not required, but it's costly. Whereas DRAM, that's a dynamic RAM, it consists of capacitors and the data that is stored in the form of capacitors. So capacitors charges when the data is 1 and don't charge if data is 0. So it requires a refreshing circuits as a leakage of current in the capacitor can occur. So they need to be refreshed to the data. It is slower and has a higher access time. It is cheaper in comparison with SRAM. The fundamental difference between static RAM and the dynamic RAM is the architecture and with what material it is made. If it is MOSFET transistor, it is static. If it is our capacitors, it's dynamic. Then we will look into the Linux kernel. The core of the Linux system is its kernel. Like Windows has its kernel, it's Windows NT. Similarly, Linux has the kernel, we call it as a Linux kernel. The kernel controls all the hardware and the software on the computer system, allocating hardware when necessary and executing software when required. Let me take you through the little history class before we completely explore the Linux kernel. If you have been following the Linux world at all, no doubt you have heard the names. You might have heard the name Linus Torvalds. Linus Torvalds. Linus is the person responsible for creating the first Linux kernel software when he was a student at the University of Helsinki. He intended it to be a copy of the Unix system. At the time of a popular, at that time, the Unix system was the popular operating system, and mostly all the universities used to use this Unix system. Now, enough of history. Let us deep dive into the functionality of the kernel. The kernel is primarily responsible for four main functions. The first one is one of the primary function of the operating system kernel is memory management. Not only does the kernel manages the physical memory available on the server, but it can also create and manage virtual memory or memory that does not actually exist. And it does that, it creates that virtual memory by using space on the hard disk called the swap space. So now a virtual memory, as you interact with a program, part of it may be in physical RAM while the rest of the program is on the hard disk as virtual memory, because virtual memory is slower than the RAM. User may notice the computer slowing down while it uses virtual memory. Now the memory locations are grouped into blocks called pages. The kernel locates each page of memory either in physical memory or the swap space. The swapping out memory pages for running applications continues for as long as the system is running. And the second function of Linux kernel is software program management. The kernel controls how the Linux system manages all the processes are running on the system. The kernel creates the first process called init. Kernel starts and then it creates a first process called init process to start all other processes on the system. When kernel starts, it loads the init process into virtual memory. As the kernel starts each additional process, it gives a unique area in virtual memory to store the data and the code that process uses. Now, some Linux implementations contain a table of processes to start automatically on boot up on Linux systems. This table is usually located in the special file called etc init tabs. Now I will go to the now in addition to system memory management and software program management, it also takes care of hardware management and then file system management. So now let's look into hardware management. So in hardware management, still another responsibility for the kernel is hardware management. So any device that Linux system must communicate with needs driver code inserted inside the kernel code. The driver code allows the kernel to uh, pass data back and forth to the device, acting as a middleman between applications and the hardware. So fundamentally, there are two methods that are used for inserting device driver code in the Linux kernel. The first one is drivers compiled in the kernel. That's the one way. Second one is driver module added to the kernel. These are the two methods the kernel uses normally. The Linux system identifies hardware devices as a special files. That's what the most important concept to be put in your mind about Linux is uh, everything in Linux is a file. Everything in Linux is a file. So the Linux system identifies even hardware devices as a special files called device files. These are the classifications of device files. First one is character. Character device files are for devices that can only handle data one character at a time. So most types of modems and terminals are created as character files. Block files are for devices that can handle data in large blocks at a time, such as disk drives. Now the second one is block. The network file type block is the one which is network file type are used for devices that use packets to send and receive data. This includes network cards and a special loopback device that allows the Linux system to communicate with itself using common network programming protocols. Then the third one what we have is a node or network. So Linux creates a special files called nodes, nodes, nodes for each device on the system. All communication with the device is performed through the device node. So each node has a unique number pair that identifies it to the Linux kernel. And the last one of the last function of the Linux kernel is the file system management. So unlike some other operating systems, the Linux kernel can support different types of file systems to read and write data to and from hard drives. So besides having over a dozen file systems of its own, Linux can read and write to and from the file systems used by the other operating systems as such as Microsoft Windows. If you see the examples that I have mentioned on the screen, ext, ex3, ex4, these are Linux extended file systems. These are fundamental and widely used in Linux. So these are called the original Linux file system, that ext, ext2, ext3, ext4. Whereas NTFS, NTFS. So this is for the to support for Microsoft NT file system. What is Microsoft NT? Microsoft NT is a kernel for the Windows. Then proc, access to the system information, and MS-DOS, Microsoft FAT16. These are all different file systems that can be supported by the Linux kernel. So any hard drive that a Linux server accesses must be formatted using one of the file system types that I've just mentioned. So now from Linux kernel, we will move on to GNU utilities. So besides having a kernel to control hard drives, a computer operating system needs utilities to perform standard functions such as controlling files and programs. While Linus Torvald created the Linux system kernel, he had no system utilities to run on it. Fortunately for him, at the same time he was working, a group of people were working together on the internet, trying to develop a standard set of computer system utilities that mimic the popular Unix operating system UNIX. That was the popular operating system during these days when Linus was working on Linux. So the GNU organization, don't worry, I will tell what is GNU. GNU is nothing but GNU stands for GNU's not Unix. That's it seems little weird, but that's what it is. GNU means GNU is not Unix. So developed a complete set of Unix utilities but had no kernel system to run them on. So Linus has developed Linux kernel, whereas GNU organization has developed a complete set of Unix utilities but had no kernel. So now these two things should be married. So these utilities were developed under a software philosophy called open source software, that is OSS, while the bundling of the Linux kernel and the GNU utilities is often just called as Linux. After marry happened between Linux kernel and GNU utilities, the output that has come out is called as Linux or Linux. You will see some Linux purists on the internet refer to it as a GNU Linux system. So in spite of just calling it as a Linux, because Linux that doesn't take the contributions that were done by the GNU organization. So that's why many of the Linux purists they refer Linux as GNU Linux system to give to give at least some amount of credit to the GNU organization for its contributions to the cause. So if you look into the core GNU utilities, the GNU project was mainly designed for Unix system administrators to have a Unix-like environment available. This focus resulted in the project porting many common Unix system command line utilities. The core bundle of utilities supplied to the Linux system is called core utils package. Core utils package, that is COREUTILS. core utils package. So the GNU core utils package consists of three parts. The first one is utilities for handling files, and second one is utilities for manipulating text, and the third one is utilities for managing processes. So the next we are going to look into is one of the utilities of such kind, that is the Linux shell or GNU Linux shell. The GNU Linux shell is a special interactive utility. It provides a way for users to start programs, manage files on the file system, and manage processes running on the Linux system. The core of the shell is the command prompt. The core of this shell is command prompt. The command prompt is the interactive part of the shell. It allows you to enter text commands, and then it interprets the commands and executes them in the kernel. The shell contains a set of internal commands that you use to control uh, things such as copying files, moving files, renaming files, and displaying the programs currently running on the system, and stopping the programs also running on the system. Besides the internal commands, the shell also allows to enter the name of a program at the command prompt. The shell passes the program name of to the kernel to start it. So you can also group shell commands into files to execute as a program. Those files are called shell scripts, that we are going to look into the shell scripts in next part of this module. We are going to deep dive into the shell scripts. This shell scripts provides great flexibility in creating utilities for commonly run commands or processes that require several commands grouped together. So now we will look into the bash shell of the utilities. So as we discussed in the previous slide, the default shell used in all Linux distributions is the bash shell. The bash shell was developed by the GNU project as a replacement for the standard Unix shell called the Borny shell after its creator. It was named based on after its creator, Borny. So the bash shell name is a play on the wording. It refers to the Borny again shell. That's what the bash means. Bash, BASH, means Borny B again shell, SH. So we can see some of the Linux shell types. SH is the basic one. Then that's the Borny shell. It was developed by Stephen Borny at AT&T Bell Labs. And what the about this Borny shell? It's a simple, lightweight shell that runs in low memory environments but has full compatibility with the Bash shell. And second one we have is CSH, uh, C shell. It was developed by Bill Joy at University of California. Then we have KSH, we call it as a corn shell. So it was developed by the David Korn at AT&T Bell Labs, and the shell named after the corn, David Korn. And it is a programming shell which is compatible with the Borny shell, but supporting advanced programming features like associative arrays and floating point arithmetics, which are not supported by the Borny shell or simple SH shell. Then we got S bash. This is by and large the default shell, and which is widely used by the many Linux administrators. So we call this shell as a Borny again shell. So it was developed by Brain Fox for the GNU project. The name is also descriptive of what it did, bashing together the features of SH, CSH, KSH. That is the reason the name also given in such a way that Borny again shell. So whatever functionality or features can be done by SH, that's Borny shell, CSH, that's C shell, corn shell, KSH, all can be incorporated into common shell, that is called Borny again shell. Then we have TCSH, that is 10x C shell. C shell, this was developed by Ken Greer at Carnegie Mellon University, and it is a shell that incorporates elements from the C programming language into the shell scripts. And finally, we have ZSH. It is an advanced, very advanced shell that incorporates features from Bash, TCSH, and Korn, providing advanced programming features, shared history files, and themed prompts. Then we will move on to window management software. Window management software, or simply we can call it as a window manager. So then after that we will go for the AS, that's application software. So here we will explore a little bit about the Linux desktop environment. Let's turn the clock before we explain about window management software. So if you turn the clock, if you rewind back, then only we can understand why this window management software and an application software has been added into the Linux kernel and GNU system utilities. In the early days of in the early days of Linux, maybe around the early 1990s, all that was available was a simple text interface. We call it as a console text interface to the Linux operating system. This text interface is allowed administrators to start programs, control program operations, and move files around on the system. With the popularity of Microsoft Windows, computer users expected more than the old text interface to work with. This spurred more development in the open source system community, and the Linux graphical desktop emerged. This is what the background of how this Linux window management software and then graphical desktop has emerged. So it has begun with the X window system. Uh, the X window system, it consists of two basic elements. One controls your video environment, the video card in your PC and your monitor, and it display fancy graphics on your computer. The Linux software needs to know how to talk to both of them. The X window software is the core element in presenting graphics. Then we have the core X window software that produces a graphical display environment, and it controls how Linux applications can present fancy window and graphics on your computer. Then the core X window software produces a graphical display environment, but nothing else. Although this is fine for running individual applications, it is not useful for day-to-day computer use. So no desktop environment allows users to manipulate files or launch programs. To do that, you need a desktop environment on top of the X window system software. So there are different types of desktops at this moment are available. So one of them is the KDE desktop. The KDE desktop was first released in 1996 as an open source project to produce a graphical desktop similar to the Microsoft Windows environment. The KDE desktop incorporates all the features you are probably familiar with if you are a Windows user. So let's go into the KDE desktop and see how does this looks. So this is how your KDE desktop looks, and the bar at the bottom here, you can see this is our bar. The bar at the bottom of the desktop is called the panel. The panel consists of the following very important major parts. The first one is the K menu. The K menu, we call it as a K menu. Much like Windows, it consists of start menu. Here it is, start menu, and the K menu contains links to the start installed application. It is by and large similar to our Windows management, Windows software. And after that you will have a panel, and then the program shortcuts you can find. These are the quick links to start applications directly from the panel, and you will have the taskbar on the rightmost. So the taskbar shows icons for the applications currently running on the desktop, and then finally you also have the applets. These are the smallest. Here you can see these are the smallest. These are small applications that have an icon in the panel that often can change depending on information from this application. It's a complete replica of Windows management, Windows software, Windows graphical user interface. Here you can see this is our K menu, and then here you have a program shortcuts. This is your complete panel or bar, and this is the applets. So now let's get back to the application software section, and the next which is available in pipeline for us is the GNOME desktop. uh, the GNU Network Object Model Environment. That's what the abbreviation of GNOME. This is very famous one. The GNOME desktop is another popular Linux desktop environment, first released in 1999. GNOME has become the default desktop environment for many Linux distributions. However, the most popular is Red Hat Linux. So let's look into the GNOME desktop too. So this is our GNOME desktop. This is how it looks, and so here GNOME, the GNU Network Object Model Environment, that is our GNU. Although GNOME choose to depart slightly from the standard Microsoft Windows look and feel, it incorporates many features that Windows users are comfortable with. It consists of a desktop area for icons, and a panel for, this is the panel for showing running application, and drag and drop capabilities. You will get a drag and drop capabilities too. Then one more one more desktop type that we have is the Unity desktop. The Unity desktop, if you are using the Ubuntu Linux distribution, you will notice that it's somewhat different from both KDE desktop and GNOME desktop environments. So because it's founded by Canonical, the company responsible for developing Ubuntu, has decided to embark on its own Linux desktop environment called Unity. So this is the single desktop environment for workstations, tables, and mobiles. It's famous for the Ubuntu, and this is how it looks. The Unity desktop gets its name from the goal of the project to provide a single desktop experience for workstations, tablet devices, and mobile devices. The Unity desktop works the same whether you're running Ubuntu on workstation or a mobile phone. So you can clearly observe various example of Unity desktop in your screen. So then what we have is an application software that we have discussed so far, which adds a graphical user interface to the window management software. So in addition to whatever we have discussed so far, uh, we will add few more. We will extend this discussion for few more graphical desktop environment that are available here. So the downside to a graphical desktop environment is that it requires a fair amount of system resources to operate properly. Example, in the early days of Linux, a hallmark and selling feature of Linux was its ability to operate on older, less powerful PCs that the newer Microsoft desktop products could not run on. However, with the popularity of KDE and Genome desktops, that has changed because it takes just a much memory to run a KDE or Genome desktop, the latest Microsoft desktop environment. As the latest, it is as similar to the latest Microsoft desktop environment. So there was a huge development that had happened on application software also. And if we extend our discussion, so the following are the few more desktop environment that are available in the market. The Fluxbox XFCE JWM. This is Joyce Window Manager, a very lightweight desktop, ideal for the low memory and low disk space environment. And FVWM and an FVWM 95. These also support some advanced desktop features such as virtual desktops and panels, but runs in low memory environments. This is what the complete details about the kernel or Linux. Linux we have discussed from the Linux kernel. Then we moved on to the GNU utilities. Then we moved on to the window management software, then application software. So now it's time for the put everything together, and so we will look into various Linux distributions. Now that you have seen the four main components required for a complete Linux system, you may be wondering how you are going to get them all put together to make a Linux system. Fortunately, other peoples have already done that for you. So a complete Linux system package is called a distribution. A complete Linux system package is called a distribution. Many different Linux distributions are available to meet just about any computing requirement you could have. Most of the distributions are customized for a special user group such as business users, multimedia enthusiasts, software developers, average home users. Each customized distribution includes the software packages required to support specialized functions. So, such as audio and video editing software for multimedia enthusiasts, or compilers and integrated development environments for software developers. So let's begin, and let's look into the each distribution that are available based on their need. So the first one what we have is a core Linux distributions. A core Linux distribution contains a kernel, one or more graphical desktop environments, and just about every Linux application that's available pre-compiled for the kernel. It provides one-stop shopping for a complete Linux installation. The famous one is Red Hat, a commercial business distribution used mainly for the internet services, mainly for the internet servers. And we have Fedora, a spin-off from Red Hat, but designed for home use. And we have Debian. Debian is a popular with Linux experts and commercial Linux products. Then we have OpenSUSE. OpenSUSE are different distributions for business and home use. Then we have Gentoo. Gentoo is a distribution designed for advanced Linux users and containing only Linux source code. Then finally, what we have is a Slackware. Slackware, okay, yeah. Slackware, one of the original Linux distributions that sets and popular with the Linux geeks. Then the second one, what we have is a specialized or advanced Linux distributions. A new subgroup of Linux distributions has started to appear, not too long, just recently. They are typically based on one of the main distributions, but contains only a subset of applications that would make sense of specific area of use. Let's begin with CentOS. CentOS, I really like it. CentOS, so a free distribution built from the Red Hat Enterprise Linux source code, and we have Ubuntu. Ubuntu we are going to widely use in this course. Of course, CentOS also we are going to use in this course, but when we are working on Kubernetes, that time we are going to use CentOS. Even Jenkins, when we work with Jenkins, also we are going to use CentOS. So now Ubuntu, a free distribution for school and home use, and we have PC Linux OS, a free distribution for home use and office use. Then Mint, Mint, a free distribution for home entertainment use. Then we have Dyni Borlik. It's a free distribution designed for audio and MDA application. Then the final one is Puppy Linux. Puppy Linux. I think Puppy, it's dog's name. That's good. So a free small distribution that runs well on the older PCs. That's just a small sampling of specialized Linux distributions. These are literally hundreds of specialized Linux distributions, and more are popping up all the time on the internet. No matter what your specialty, you will probably find a Linux distribution made for you. That's why you should love Linux. Actually, I really love Linux. After I started working in corporate IT companies and other companies, I literally fell in love with Linux. More than I spend time with my girlfriend, I used to spend a lot of time with the Linux. So Linux is love for me. Okay, so now we will move on to the next one, that is the Linux Live CD. A relatively new phenomenon. It has started just few years back in the Linux world. Is the bootable Linux CD distribution. This lets you see what a Linux system is like without actually installing it. This is an excellent way to test various Linux distributions without having to mess with your PC. Just pop in a CD and boot. All the Linux software will run directly from the CD. So you can download lots of Linux live CDs from the internet and burn onto a CD to test drive it. So Nopix, a German Linux, the first Linux live CD developed. Then PC Linux OS, a full-blown Linux distribution on a live CD. Then we have Ubuntu. Ubuntu Live CD is also available, a worldwide Linux project designed for many languages. Then we have Slacks, a live Linux CD based on Slackware Linux. Then we have Papier Linux, a full featured Linux designed for older PCs. That's just a small sampling of specialized Linux distributions. It's a ocean. It's bigger than the ocean. So you will have a hell number of Linux distributions. If you want to look into that, you just go to the Wikipedia of the Linux and just search for it. So this is the Linux distribution Wikipedia page. If you just go through it, here you have your diagram. This is what I'm talking about. This big it is. Slackware Linux, just now we talked. Then you have Debian. Then what you have ahead is Red Hat. Here it is. You have a Red Hat. You have a CentOS. You have a Red Hat Enterprise. And there are hell number of distributions are available. So here you can see from 1992 till 2000, almost 2022, you are going to find all types of distributions here from CentOS, everything, almost all. So this is huge. This is fundamentally huge. So you just type Linux distros Wikipedia, just enter it and zoom it and see it's a ocean. It's an ocean. Whatever we are discussing is just a tip of a drop of uh, ocean. That's it. Let me put it into proper way. See, from 1992 till 2022, you can clearly see Slackware. These are all the distributions, and you can find all the distributions at a one place. Uh, just go through it. So no matter what your specialty, you'll probably find a Linux distribution for you. So here in this chapter, we have discussed the Linux system and the basics of how it works. The Linux kernel is the core of the system, controlling how memory, programs, and hardware all interact with one another. The GNU utilities are also important piece of the Linux system. The Linux shell, which is the main focus of this part of this module, is the part of the GNU core utilities, and this part also discussed the final piece of your Linux system, that's the Linux desktop environment. Things have changed over the years, and Linux now supports several graphical desktop environments. So this chapter also discussed various Linux distributions, though you can see it is on your in front of your eyes from the Wikipedia page. So your Linux distribution bundles the various parts of Linux system into a simple package that you can easily install on your PC. So the Linux distribution world consists of full-blown Linux distributions that include just about every application imaginable, as well as a specialized Linux distributions that include applications focused only on a special function. So in the next sessions or slides, you will look at what you need to start your command line and shell scripting enterprise. You will see what you need to do to get the Linux shell utility from your fancy graphical desktop environment. These days, that's not always an easy thing. So have a look at this Linux distributions from the Wikipedia. So far, we have seen what is Linux and what is Linux kernel, what is Windows software management and application level and GNU utilities, and what all different Linux OSs that are available. Distributions, basically we call it in Linux terminology. So all these things we have seen. So now we have entered into a stage that where so we have to access that Linux to do some operations. That how do we do? So that's what we do it through shell, and this is what we call it as accessing the shell. So what all different methods that are available to access the shell? What is the primitive one? What is the initial one? And what are the latest and updated versions of accessing the shell? So, uh, before the days of graphical desktops, the only way to interact with the Unix system was through a text command line interface. This is called CLI. that is command line interface provided by the shell. The CLI allowed the text input only and could display only text and rudimentary graphics output. Because of these restrictions, output devices were not very fancy. Often you needed only a simple dumb terminal to interact with the Unix system. A dumb terminal was usually nothing more than a monitor and a keyboard connected to the Unix system via a communication cable, usually a multi-wire serial cable. So this simple combination provided an easy way to enter text data into the Unix system and view text results. That's what our command line interface. This is one way. So as you all know, things are significantly different in today's Linux environment. Just about every Linux distributions use some type of graphical desktop environment. However, to enter shell commands, you still need a text display to access the shell's CLI, that's command line interface. The problem now is getting to one. So sometimes finding a way to get a CLI in a Linux distribution is not an easy task. So that's the reason before I taking you to the ride of the Linux, I would like to know about how you can access this shell in Linux. So one of them is through console terminals. We call it as a console or console terminals. So one way to get to a CLI, that's command line interface, is to take the Linux system out of graphical desktop mode and place it in the text mode completely. It will neither have window management software or application. So those both two layers won't be available in this. So it will be completely in text mode. So this provides nothing more than a simple shell CLI on the monitor, just like the days before graphical desktops. This mode is called Linux console because it emulates the old days of a hardwired console terminal and is a direct interface to the Linux system. So in most Linux distributions, you can access one of the Linux virtual consoles using a simple keystroke combination. Usually, you must hold down the Control plus Alt key combination and then press a function key. It could be F1 through F7, some based on your laptop, for the virtual console you want to use. So function key F2 produces a virtual console 2. F3 produces a virtual console 3, F4 produces a virtual console 4, and so on. So this is one way, one type. So just to demonstrate this console terminals and how it works, so let's get into the Windows. I'll show here. So because in this I have installed WSL, that's Windows Subsystem Linux. Basically, it's Windows System Linux for the Windows. That's what I have installed. So let's get into that. See, WSL. So I will open it and let's see. So now WSL, it's an Ubuntu. It's an Ubuntu system. It is not completely just a tool in it. It is an OS. It's a distribution, Ubuntu distribution we have here. So uh, as there is a complete Ubuntu distribution, so I have to log into it. I have to access that shell. How can you do it? How can I do that? I can do it through console. So this is that console. So here now we are working in a completely different system. That is, you can see Ubuntu 22.04.1 LTS. This is a completely different distribution. So now what is there in front of is just a console. This system, this Ubuntu system, Ubuntu distribution does not have any kind of graphical uh, interface attached to it. So that's why you can access only through this console. So if you want to see, let's ask who am I. So I'm a root user in this, and then let's check. So I think there are a huge amount of files. So let's see, where are we? It is in Windows System 32. That's where it's a mount point, and see, okay, that's where we are. And then let's uh, go to the root. Okay, see, this is what I'm talking about. This is how a normal Linux system consists of. These are all these repositories, or all these directories. All these directories will be present in each and every Linux system, irrespective of distributions. So you can clearly see this. This is how a console system works. A console system will have a console terminal. Console terminal can have only a text mode. That's it. There is no graphical user interface attached to it. So then what we have are graphical terminals. So the alternative to using a virtual console terminal is to use a terminal emulation package from within the Linux graphical desktop environment. A terminal emulation package simulates working on a console terminal but within a desktop graphical window. So this is how a graphical terminal looks. I will demonstrate the graphical terminal also, how it looks. For example, we are in a Windows 10 machine. So mine is in, let's consider as a Windows 10. So now it has a Windows software management as well as application. So that's why it's everything is graphical, you can see. Now if I want to access the shell of this window, this Windows system of my laptop, how can I do that? I can do it through this way. I'll go here and then I'll type Windows PowerShell. That's it. I got it. This is what we call it as a graphical terminal. So here you can do a lot of changes. You can see mark, edit, defaults, properties. Here you have properties. You can change layouts, you can put colors, terminals. So this is what we call as a graphical terminal. So the shell can be accessed either through console. It's completely text mode, whereas graphical, so that means literally like your Windows system, your Ubuntu distribution also will have a graphics and graphical user interface, everything. And then you go and type or go to the store, go to their application store and applications, and you find out the uh, shell and click on it and you'll get it. So that's the difference between uh, um console terminals and then graphical terminals, and these are the two ways of reaching the command line in Linux. So then accessing the CLI via graphical terminal emulation that we have seen, the graphical desktop environment offers a great deal more variety for CLI access than the virtual console terminal does. Many graphical terminal emulator packages are available for the graphical environment. Each package provides its own unique set of features and options. Some popular graphical terminal emulator packages are shown below. You can go through that one by one. The most famous one is genome terminal, and then terminator, console terminal, ux term, eterm, and rxbt unicode xterm, and then finally rxbt unicode. So basically xterm is the last one. However, so these are the different graphical terminal emulator packages, and if you install this and you can attach that graphics to your system. So um, I think let's uh, in ubuntu in ubuntu unity desktop example, the xterm, this is the one, is installed by default. You can access it, you can go into the dash and then search and type xterm. So xterm shows up in the dash home area as an application, and then so you can change it also. You can change it from xterm. You can install uxterm also. So this is how these are the some of the terminal emulator packages are available in the market, and then you can uh, use this in your graphical user interface to access the shell. To start learning Linux command line commands, you need access to a CLI. In the world of graphical interfaces, this can sometimes be challenging. So, in the previous sessions or slides, we have discussed in detail about different interfaces you should consider to get to the Linux command line. So next we explored then we explored in detail accessing the CLI via a virtual console terminal. Then we covered Xterm terminal emulator package. Xterm was the first terminal emulator available for Linux. It can emulate older terminal hardware such as VT, Tektronix terminals also. Now in this slides, you will be start looking at the Linux command line commands. It walks it takes you through the commands necessary to navigate around the Linux file system and to create, delete, and manipulate files. So let's begin with the basic bash shell commands. The GNU bash shell is a program that provides the interactive access to the Linux system. It runs as a regular program and is normally started whenever a user logs into a terminal. The shell that the system starts depends on your user ID configuration. The default shell used in many Linux distributions is the GNU bash shell. So let us explore all the basic commands in bash shell scripting first, and then we will move on to the uh, advanced one. So the first one is the etc passwd file. Contains a list of the system user accounts along with some basic configuration information about each user. Here is a sample entry from a etc passwd file. So each entry has 7 data fields with fields separated by colons. The system uses the data in these fields to assign specific features for the user. Most of these entries are discussed in more details in later sessions. For now, just pay attention to the last field which specifies the user's shell program. So, uh, before understanding how it works, let's get into the WSL and then let's try to look into it. So ls, here we do not have anything, so let's get into cd, it's etc. So here we have a lot of files, so let me clear all. Now cat passwd, so this is what your file is. You can say, you can take one example. So if you take this as an example, from this part to this part, so you have total 7 fields: 1 2 3 4 5 and then 6 7 8. So total, this is 1, this is 1 and this is 1, so total you have 7 fields up to here. Okay, so now we will look into the each and then we will move into the another one. So this is one example we have taken. So now the first in this example, this means uh, you can see this example when Surya Charan logs into the Linux system, the bash shell program is automatically started. So now if you look into this, you can just take any one example. So I've taken this one only, Charan, and this example. So the first one is number 1. Here you can see this is a number 1. Okay, okay. So this is the example we have taken. So here Charan, this is one, and then first one is the username of that user. So let's look into the each component of the passwd file. So for that, what will we do? We'll type cat of passwd file and then pipeline, then grep, and I'll take Charan as a user. So here two users are there which consists of a Charan. So we'll take this example, the second one. So Charan, and then so now the first part of uh, this complete sentence is username. The first one is username. It is used when user logs in. It should be between 1 and 32 characters in length. So the second part, here you can see X, and here you can see this is our second part, and the second part is password. An X character indicates that encrypted password is stored in some other file, that's shadow file. So let's just look into that file once. Shadow file, that is also in etc, directory only. So please note that you need to use the passwd command to compute the hash of a password typed at the CLI, or to store or update the hash of the password in etc and cdc and shadow file. Cat shadow sorry shadow file. It's cat shadow. Let's see. This is what the encrypted password for Charan. Even I forgot what's this password. I do not know. So this is what the encrypted password for this guy, and for Surya Charan this is something else. Okay, so that's how it works. So let's clear it off, and then we'll get back to the previous one. Yes, this is what we are looking for, and we'll move on to the third part of this, that is user id. The third part, user id, that is 1002 is our user id for Charan. And each it's also called as a uid. Each user must be assigned a user id, that's uid. Uid 0 is reserved for root, and UIDs 1 to 99 are reserved for other predefined accounts. Further, UID from 100 to 999 are reserved by system for administrative and system accounts groups. So let me demonstrate that again. So cat and then passwd. Okay, there are a lot of passwd. Okay, so here if you look into this, all the files, there are different users, not one, there are plenty of users, and it begins with the 0 user id. So 0 user id is for root user, you can clearly see. This is what 0 user id. 0 user id is for the root user, and 1 user id, this is for daemon. And then bin binary files will take 2, and system will take 3, and sync will take 4, and games and lot of other will take 4. So these are 0 to 99. Whereas if you, and docker and these system administrative or system related software will take see UIDD TSS 106, they have taken other number. And Surya Charantesa, this is another user. He took 100 and Charan has taken 1. And test is another user, he has taken 1001, and Charan has taken 1002. So this is how user IDs are assigned. Basically 0 1 to 9 are reserved for the predefined accounts, and 100 to 99 are specifically for system administrative or accounts and groups related work, and more than 1000 is what a normal user we get it. So let's clear it again and get back to the work. Okay, so now for the is fourth one for us is group id. We call it as gid. The primary group id stored in group file. So let's look into that group file also. So cat and then group. Okay, okay, this is what our group file is. Group files, you can see here whatever the groups that this distribution consists of, all group, and then their group IDs are given. Docker, we have Docker group ID, that's 1001, and Charan 1003, test 1002, and admin 117. These are different group IDs that we have. And then the fifth one what we have is user ID info. So here we have user ID, fifth one, user ID info or GCOS. The comment field, it allows you to add extra information about the user, such as user's full name, phone number, etc. This field used by finger command. And the next one what we have is, after fifth one what we have is, uh, this is some information, this is a single field, this is some information about this user. And after that what we have is home directory. Home directory, the absolute path from here to here, the absolute path to the directory the user will be in when they log in. That's what is given there. If this directory does not exist, then user directory becomes a root one. Okay, and the last one which is left is the seventh one, that is command or shell. So command or shell, that's the directory of the command or shell. The last one, the seventh part, is the absolute path of a command or shell, that's /bin/bash. Typically this is a shell. Please note that it does not have to be a shell. For example, system admin can use the no login shell, which acts as a replacement shell for the user's account. So if shell set to sbin /no login, and the user tries to log into the Linux system directly, the sbin no login shell closes the connection. So these are the different components of that passwd file. So, and this is very much useful because it consists of users and groups and as well as passwords. So we have looked into all of the information which is primarily necessary for system admins. So now, using the shell prompt, after you start a terminal emulation package or log into a Linux virtual console, you get access to the shell CLI prompt. The prompt is your gateway to the shell. So this is the place when you enter the shell commands. This is the place where you enter the shell commands. Now, the default prompt symbol for the bash shell is the $sign. This symbol indicates that the shell is waiting for you to enter text. Different Linux distributions use different uh, symbols, use different formats for the prompt. On this Ubuntu Linux system, the shell prompt looks like the following way. So the $symbol. And on the CentOS Linux system, it completely looks like the following way. Beside acting as your access point to the shell, the prompt can provide an additional helpful information. In the two preceding examples, the current user ID, the first one, the current user ID name, you can see the current user ID name. This is the current user ID name. Surya is shown in the prompt. Also, the name of the system. The name of the system is also shown as a Ubuntu 01. So think of the shell CLI prompt as a helpmate, assisting you with your Linux system, giving you helpful insights, and letting you know the shell is ready for the new commands. Another helpful item in a shell is the bash manual. So before going to the bash manual, I would like to demonstrate the shell prompt. I would like to shell prompt in Ubuntu as well as CentOS. What is the difference between the Ubuntu and then CentOS? For that, you just log into your AWS if you have, or you just follow it. Then go to the EC2 instances and see in which region you are. It's fine. I'm in North Virginia, that is US East 1. That's absolutely fine. Then I would I will go for launch an instance. I'll name it as CentOS. Then I want a CentOS 7. So quick start. Okay, I'll go for the marketplace and I'll search for CentOS 7. I got it. I got the CentOS 7. I'll select it. I'll click OK. Now, okay, my AMI is ready. And then now I'll select, okay, T2 micro is also fine. That's fine. It's just to demonstrate uh, a prompt. So T2 micro is more than enough. Then I'll create key pair CentOS 7 KP, and then I'll uh, I have to create security group. So CentOS 7, the name is fine, and then this is by default, everything is fine. So I just want to access this SSH through my IP only. So rest all is absolutely fine. So let me, okay, everything fine. Let me launch it. By the time this get launched, I will, okay, system is pretty slow. Okay, it's successfully launched, but by the time get launches, okay, apologies for inconvenience, and let me go to downloads. This is my, and then I'll copy here. Okay, this is CentOS, and let me, by the time it gets started, I will launch one more instance. I'll name it as Ubuntu, and then I'll take Ubuntu 20, or whichever is fine. 20, I'll go for 20. Ubuntu 20 LTS, and rest all fine. T2 micro is also okay. Let me create a new key pair, that is okay, Ubuntu KP. That's fine. Fantastic. Let me create it. Then again I have to edit my security group. So here I'll give name Ubuntu SG, and then here also I'll change the name Ubuntu SG, and from my IP I want to access this from my IP. Rest all fine. Let me launch it. So by the time I'll bring this into my folder, so where I can open Okay, let me paste it. Okay, got it. So now I think I both should be running. Yeah, so let me open git bash here and put it on right side, and I'll open one more git bash, and sorry, I put it in left side, and I'll open one more, and I'll put it on right side. Yeah, so now we'll launch the CentOS first because it's running. So go to the network, sorry, sorry, let's click on connect and then SSH client. Copy this, I think this is through git, and then paste it, and yeah, it's asking for uh, permission. Give S, this got permanently added, and your CentOS is ready. And then we will get back to the another instance, that's Ubuntu, and then click on connect again, copy the link, and launch it and access that through this is also asking for the permission, and I gave it. Okay, it's all done, all set. Okay, let me clear this, and let me zoom in a little bit more. Yes, fine. Let me clear this also. Yeah, both are ready now. On left you see CentOS, on right you see Ubuntu. So first we'll look into um, Ubuntu. Sorry, first we'll look into CentOS, and then we'll look into Ubuntu and parallelly. So here, who am I? Who's the user? The user is CentOS. And here, who's the user? The user is Ubuntu. So the first part is Ubuntu. And then host. What we have is host. So this is the host name. And here, this is the host name. Basically, these are the IPs. These are the public IPs. So the private IP. The private IPs are the host names here. And then what we have, the important thing to be looked at is here, this part, tilde, tilde or tilde, and then a square bracket, and then this dollar symbol. Dollar symbol is common for the both, and tilde is also common for the both. But whereas uh, this one has a colon, and then this one doesn't have a colon, and the difference is, you just compare the Ubuntu and the CentOS. CentOS has a square brackets, and then Ubuntu does not have anything other than colon. And then the prompt dollar symbol is common for both. So now let's check. It's a CentOS, it's not the root user. So now it's a normal user. Now let's see what happens if we become the root user. So sudo I. So now it has become a root user. The dollar symbol has been changed into hash or pound symbol. Let's see here what happens. And again sudo and I. So again here also the dollar symbol has been changed into hash symbol or pound symbol. So that's what the main important I would like you to note down. So the first difference is it starts with the square brackets, and here there are no square brackets. And whereas a root user is common, sorry, username, then at the rate of is common, then at the host name, then we'll have a tilde symbol, but here you will have an additional colon, and dollar symbol for the normal user, pound symbol for the root user. So now what does a tilde symbol basically conveys? What does tilde symbol conveys is you are in home directory of that user. So now what is the home directory for root user? Let's see. Pwd. Yes, that's the /root. This is the home directory for the root user. Let's check here. What's the condition? Pwd. Yeah, obviously this is the root user of the home directory, so that's what this tilde symbol shows. And similarly, if you become a CentOS, so now you become a normal user. Now there is no more the tilde symbol. Let's check why. Because now you're still in a root user. But here if you check CentOS and then tilde symbol is still exists. Thus that means at that time the directory is where the directory where you were there is the home directory of the CentOS. Let me take you there. cd home CentOS. See, now it has got changed into tilde. So pwd. So to keep it simple, the same logic applies in Ubuntu also. To keep it simple, what I'm trying to say is when you find a tilde symbol here or here, let me change to su and then Ubuntu. Sorry, sometimes it happens. Okay, uh, here again /root complete, it got added. So let me go home and then Ubuntu. Okay, so when you find either tilde symbol in CentOS or in Ubuntu or CentOS, the logic remains same. If tilde symbol is there, you're in the home directory of that user, whoever user, whether it is a normal user or whether it is a root user, it doesn't matter. If there is no tilde symbol and there is the directory mentioned, root or whichever directory, that means you are in that directory with a different user. So that's what it says, and these are the between differences between Ubuntu and CentOS. So get back to the now let's get back to the slide again. So now I hope it's pretty much clear, and uh, you got it very rightly. So let's move on to the next stage. So what we have next is interacting with bash manual. So you should become familiar with the manual because it's invaluable for working with commands, especially when you're trying to figure out what various command align parameters are. For example, if you take the first one, when I type man, so here I'm using just Windows sub. Oh, sorry, these are Linux. I'll go for the Ubuntu with the WSL. So I think this fonts are more than enough. So let me drag it up and then bring it. Yes. So when I type man and then man, so I got a detailed manual. So basically it talks about how to interpret the commands and then options and then arguments, and this is a in detailed documentation where you can get to know how to use the commands and options and arguments. How can you leverage these different types of options which are attached to the commands? So that's it, it will have a huge benefit. So let's go through it uh, one by one. So first, whatever you find, that's it's a man. uh, you will, whatever command that, what we get is a command name, and then you will have a synopsis, basically syntax of the command. So normally how you will have is command and then command options and then arguments. So basically there are two types of command options. You can have either long options and then short options. And when you open, for example, any when you typed, when you requested for the uh, manual for any command, so this is how it opens. First it name of the command, and then it will give you a syntax, a synopsis or syntax of how you can use it, and then it will give you a description, a detailed description about that command. Then below that it will show you different options, and then it will also give you different examples, and then finally it will give you overview and defaults, and finally options, long options, short options, and it will close it with some manual pages. So this is how it works. To just get out uh, from this page, click Q, that's it. So now what will we do is uh, okay, just go through this. First we'll have a name. When you seek for an help from this man utility, so the following information it will throw you, it will throw out. First one is name. Name displays command name and a short description about that command. Synopsis shows command syntax. Configuration provides configuration information, and options describes command options. It could be a short option or long option. And description, a detailed description uh, about that command. And environment describes environment variables used with it, and files defines files used by command, and a few examples at the end. So this is how a overview of seeking a help from man utility for Ubuntu, and for CentOS it could be a different way, but for here, for CentOS you just take up the system in a completely different way. There it just okay, okay, it's gone. Let me check. Mm. So here what we have to do is, oh, even for here we use man, that's fantastic. Even for the CentOS, um, I think, yeah, that's good for CentOS. But whereas some other distributions will take some other way, but here man, we are discussing of the man because this is common for both the ways. So let's get into the uh, Ubuntu again, and then for example let me take ls. This is the famous one, most famous one. So the first one is name section. Here the short name, that is ls, the command name, and what the description, short description. Ls means list directory contents, that's what the ls command, and then a synopsis or a syntax, command syntax. First you write command name, then you mention options, then you mention argument. That's it. That's the simplest syntax. Then a detailed description. What is ls? What does it do? ls is list information about the files, the current directory by default. Sort entries alphabetically. If none of, like, C option, F, T, U, V, S, U, X, nor long option such as double hyphen sort is specified. Now, mandatory arguments to long options are mandatory for short options. So now we have some examples. See, A is a short option, double hyphen all is a long option, and both does same function. Do not what is their function? Do not ignore entries starting with dot. That's what it do. And hyphen capital A or double hyphen almost hyphen all do not list implied dot and double dot. So if you give other and hyphen b, that's a that's a small option, that's a short option. There are different plenty of other options, out of which most widely used one is l l. I'll just find out. I found I. So here is L. L means L is a short option. Use a long listing format. Long listing format. So that's what. And R is another one which we use it recursive. Sorry, reverse. The smaller one we use, not the capital R. Reverse order while sorting. And then T is the another one based on sort by time, newest first, see the time. So we have seen all those things. Let's get into the any of the system if it is available. So this is basically uh, mm, I think let me zoom in, let me zoom out. Okay, I think it's let me click Q. Okay, okay, still it's there. Let me check. ls is the base command, so nothing is there. So let me get into root. ls is the base command, so these are the information that's present in that. So if you just give ls, so this is how it shows. Then I will add one option, that is ls. I'll add l. So let's get the long list. That's the magic. No, it's not the magic. These are all written as a lower level language. These are all called, even this is called a utility. Even ls is a utility. Though these are commands, these are utilities, and these are written with a lower level language, and these are all put it as a binary files in binary directories. Okay. So now let's add T. So this is how it works. And then R. So this is how it works. And when we use all together, so now let's look into the file system of the Linux. When you log into the system and reach the shell command prompt, you are usually placed in your home directory often. So you want to explore other areas in the Linux system besides just your home directory. This section describes how to do that using shell commands. To start, you need to take a tour of just what the Linux file system looks like, so you know where you're going. So as we are almost most of the time we used Windows, so it's difficult to understand the Linux file system. The first difference you will notice is that Linux does not use derive letters in the path names. In the Windows world, the physical drives installed on the computer determine the path name of the file. Example, you can see it on top. So let me. Yeah, here it is. D drive. In that I have imlike. In that I have YouTube. In that I have iDevOps for you course. In that, in this folder, in this rep, all this stuff is there. So that's how the path of the Windows system is made up or made of. So so basically Windows assigns a letter to each physical disk drive, and each drive contains its own directory structure for accessing files stored on it. And the Windows file path tells you exactly which physical disk partition contains the file named test.doc. Just for an example, I'm taking that. So for example, if you have saved test.doc on a flash drive designated by the J drive, the file path would be j colon backward slash test.doc. So this path indicates that the file is located on the root of the drive assigned in the letter J. So let's go into that system and we'll see how it works. Okay. Mm, Example. So here I am. So let's go into this. So this is D, and see I have only two. So now if you go to the see anyone, I'll go to the mlike, and this is my YouTube, and here I have a Python course, and in this I have notes, some of the notes I have written. So if you just copy this, if you see D mlike YouTube IPython for you and notes, uh this is how it directs you to the physical drive where your files are located. This is the file system of Windows. Whereas whereas Linux completely different. This is not the method used by Linux stores files within a single directory structure called a virtual directory. The virtual directory contains file paths from all the storage devices installed on the computer merged into a single directory structure. The Linux virtual directory structure contains a single base directory called root. Directories and files beneath the root directory are listed based on the directory path used to get to them. So similar to the way Windows does it. This indicates that the file test.doc, an example, test.doc with the doc extension, is the directory documents under the directory rich, which is contained in the directory home. Notice that the path does not provide any information as to which physical disk the file is stored on. This is the fundamental and huge difference between a Windows and a Linux file system. The tricky part, you can see that clearly on the screen. /home is the, in that you have a username, documents, and then test doc. So this is the difference between a Windows and a Linux. So the tricky part about the Linux virtual directory is how it incorporates each storage device. The first hard drive installed in a Linux system is called root drive. The root drive contains the virtual directory core. Everything else builds from there. On the root drive, Linux can use special directories as mount points. Mount points are directories in the virtual directory where you can assign additional storage devices. Linux causes files and directories to appear within these mount point directories even though they are physically stored on a different drive. Shows two hard drives on the computer. For example, one hard drive is associated with the root of the virtual directory indicated by a single forward slash, only single forward slash. All those things I will demonstrate to you in a few minutes, so you don't need to worry about all those things, but just follow me. uh, Other hard drives can be mounted anywhere in the virtual directory structure. In this example, the second hard drive mounted at the location /home, which is where the user directories are located. So you can see this example. The disk 1 is the root directory or root drive, and disk 2 is also another drive we have. Though, so bin etc mount user var. So all these root directories or all these directories are attached to the root drive physically and actually in actual scenario. And some Charan, Surya, Shiva, Krishna, these are all some users, they are attached to the disk 2 physically and actually. Though it won't be, whatever data that you store in Surya's folder will be stored physically in disk 2, and whatever you store it in var will be stored in disk 1. However, for the representation in the Linux system, it doesn't consider the names or of the actual disks. It will just show as a common pattern, that is /bin or /home then /surya. That's like it shows, it considers it as a virtual directory or virtual home where everything is placed. That's it. Okay. So then we will move on to the each and every directory that present inside our Linux system. Okay, so the Linux file system structure originally evolved from the Unix file structure. So it goes like this. It consists of a forward slash. If it consists of only forward slash, it's called a root of the virtual directory, so where normally no files are placed. So this is how total, these are common irrespective of what type of distribution it's using. all these directories will be present inside the inside your Linux system. So it's the fundamental one is virtual directory, the root of the virtual directory, that is forward slash, then we have forward slash bin, the binary directory, then boot, the boot directory, then dev, device directory, then etc, it is system configuration files directory, then forward slash home, this is home directory, and then lib, library directory, and media directory, mount directory, optional directory, process directory, root home directory has been system binary directory, where and r, and then run directory, srv, sys service directory, and system directory, tmp temporary directory, usr user bin directory, var variable directory. The last five one are very important for the deployment purpose, but let's see. Let's I think go into the Ubuntu or whichever it may be. Yeah, and log into the Ubuntu, and let's explore each and every directory. Let me clear it up everything. So let me zoom out a few inches. Yes, that's right. We got up. We have all set. Now let's jump and look into the each and every directory. So here, if you see, uh, you can see the tilde symbol is present. What does that mean? Just the previous slides I have explained about this. The tilde symbol it means it's the user is the user, the directory, the existing directory, the present directory is the home directory of the user. That's what it says, the tilde symbol. Let's see what is that. pwd, of course home Ubuntu is the home directory for the Ubuntu user, so that's the reason. So now we'll begin with the root of virtual directory. So for that, what I will do is I will give cd the change, sorry, cd small, and then forward slash. It will take me to the root of the virtual directory. So let me check it. That's it. A magic. So all the directories are present in a root of virtual directory. So this is the highest level of directory above which there is no other directory present. That's what I'm saying. So irrespective of how many disks, physical disks you have attached, all will be, maybe few directories will be connected to different disks. It doesn't matter. At the end of the day, all the disks, that all the disks memory will be considered as a virtual directory. That's the root of the virtual directory, and all our directories will be present in this root of the virtual directory. See, all bin, home, opt as bin, tmp, boot, lib, everything is there, everything in that. So first, so that's what our root of virtual directory, where normally no files are placed, but all the directories will be present in this root of the virtual directory. That is with the, that is represented with a single forward slash. Then we will look into bin. So cd and then bin. So let's see what is there in it. So there is huge amount of stuff in cd bin. So bin, the binary directory where many GNU, user level utilities, are stored. You can clearly find out gmore, grep, gforce, xzcat, and then s, let me scroll up a bit. Who am I, who, which, where, wc, these are all commands that Linux commands that we use. Vim, you see vim, this is a text, it is a file writer, or And so all the commands, most of the commands, GNU utilities, these are all fundamentally a low level language files na. So that's the reason all these files will be stored in the C time example. I'll just type time here. See, you got the time. So this is a utility. It's so all these utilities, all the commands that we use in Linux will be normally user level, basically user level utilities or user level utilities. There will be sbin, that is that's a different one, but this is user level. Even for the normal level, this can be used by the whatever commands that can be used by the normal users also, like Ubuntu, Cheren. So those will be placed in this um, bin binary directory. Then we have boot. So let's get into the boot. Cd boot. Let's see what all there. So in boot, it's a boot directory where boot files are stored. So you can find out some of the boot files here. So um, what are whichever the files that are VM Linux and all those things. VM Linux. Grep example. Grep is the one which is very much useful. Let's get into the grep and see. See here you have fonts and everything, which helps in basically for booting. So the booting files, all the booting files are present in this boot directory. Then we will look into the dev directory. Let's get into the dev directory and see. Dev directory or device directory, where Linux creates device nodes. So let us check what are device nodes. See, terminals TTY1, TTY4, PPP, PTMX, PTS, random, all the most important stuff is present. This is terminals. And then we will look into home. This is widely used, so it's better. So home directory, where Linux create user directory. Whatever users that you create in this Ubuntu system, all the users will be present, will be put in home directory. So for example, Ubuntu is the one normal user. He is not the root user, he is the normal user. So that's the reason his home directory will be placed in home Ubuntu directory. So you can see that that's the Ubuntu. Okay, then we will go to the lib. So lib is a library directory where system and application library files are stored. So you can basically see sudo is very important. It's a sudoers and Python, OS, ManDB. So lot of files, GNUPG, lot of files are stored. Libraries, basically it's a library files. Then we'll go to the media. So media directory is a common place for mount points used for the removable media. So at this moment it's completely empty, because you can use it as a mount point to connect with the removable disk or removable media or pen drive. So at this moment we haven't connected anything, it's empty. So then we'll go for the mount point. Let's see what is mount directory. So at this moment it's completely empty. So mount directory is similar to that. Another common place for mount points used for removable media. Then we will jump into the proc. So proc is again a process directory where current hardware and process information is stored. Let's see some of the one example we'll take is uptime. When you type uptime, so you're getting the time and the up and how many users and load average. It's giving complete details about the PC for how long it's been up and everything. So that's what the uptime. And similarly you can give stat. Okay, stat. Mm, it's not working. Oh, okay. then sys. So this is how you can sorry, version. I would like to check version. Even version is also not working. That's fine. So this is how it gives a live information about your system. Then we will enter into the most important one, the root directory. Okay, the permission is denied to directly enter. Let's become a root user, sudoer, and then we will enter into the root directory. So now we are in the root directory. Let's check pwd. Okay, it's a forward slash root. This is a root user home directory. Normally we don't place any files in this directory. It's a root user home directory. Then let's look into the sbin. Sbin also has a lot of files. So sbin is system binary directory where many GNU admin level utilities are stored. Admin level utilities are stored. For example, this can't be used directly by example sudo, va sudo. Va sudo consists of a user names who can use the who can become a sudoer, who can take the permissions as who can take permissions and who can uh, act as as a root user. So many utilities cannot be used by a normal user, so all those users will be placed in as bin. So all those utilities will be placed in as bin. Example, a reboot is one. And then we will look into the run. So again, run directory where runtime data is held during system operation. So this is a run directory. So example, log. This is widely used. So the log information and all the information will get it from here, and user. Okay, so that's what. So it will give you runtime data regarding runtime data that's held during the system operation. So now we will look into the SRV, the server SRV, the service directory. Service directory where local services store their files. Basically, uh, this is widely used for the deployment. Anyway, we will be doing deployment in our future sessions, so we will do that. Okay, and then we have sys. This is a system directory where system hardware information files are stored. You can see kernel, system hardware, kernel, hypervisor, firmware, bus, devices, dev, all those things are related to system hardware. That information will be stored in sys. So don't meddle with this directory at any cost, at any cost. Then we have TMP. TMP is a temporary directory where temporary work files can be created and destroyed. So basically, if you want to do some experiments, we will do it in temp only. So that's what we are going to do in future sessions also. Okay. Then what we have is user. This is our user binary directory where the bulk of GNU user level utilities and data files are stored. Even basically the installations that we do, the different services, Apache to install, or Jenkins, or Java, or Maven, when you install all these services, most of the binary files will take up this user and then bin user lib basically, and then user, they go to the lib, and here it will be stored. So in this place you can find even systemd. This also has been stored here only. So this is also widely useful for the deployment again. So that's why I have told you before, I placed them in such a way that the 5 directories that we widely use for the deployment in a separate section. Then final one is var. So again var. So var is a variable directory for files that change frequently, such as log files. So let's get into the log files and we'll see. Okay, so here you have a log file and complete information about the logs. And var is also a one more directory which can be used, which we use in deployment also. So now when you log into your server, when you log into your system and reach a shell, when you log into your system and reach a shell CLI prompt, your session starts in your home directory. Your home directory is unique directory assigned to your user account. When a user account is created, the system normally assigns a unique directory for the account. You can move around the virtual directory using, so here that's what happened when I logged in. Or if you just want to test it again, we'll go to this another this is basically CentOS. Let's do it. Okay, it's CentOS. See, you should directly enter into your, yes, that's it. Where are you now? You are in, you should be in your CentOS. Is a normal user in his home directory. As it is home and then CentOS. This is the home directory of the CentOS. So even the same thing happened here also. That's the purpose. That's how you can move around the virtual directory using a graphical interface. However, to move around the virtual directory from a CLI prompt, you need to learn to use the cd command. So that's what we are going to do next. Yeah, look into the some basic Linux commands now. So we'll begin with reversing directories. You use the change uh, directory command, that cd change directory command, to move your shell session to another directory in the Linux file system. The cd command syntax is pretty simplistic. It's cd space and then destination, basically an argument. Cd is the command and then space and then argument. So the cd command may take a single parameter, a destination, which specifies the directory name you want to go to. If you don't specify a destination on the cd command, it takes you to your home directory. So let's test it with the example. So we'll log into this uh, into Ubuntu. I think it doesn't work. So let's get into WSL. So here it is. Yeah, I'll keep it this way and quit it. Let me clear the screen first. Yeah, now cd is our command and then destination. So before that, we'll check cd. Then for cd, that's it. If you don't give any argument, cd and space and enter, it will take you to the home directory. That's it. It's a root and it is in its home directory. That's what happens. Now the destination, just a minute. Yeah, the destination parameter can be expressed using two different methods. One method is using an absolute directory reference. The other method uses a relative directory reference. So now you can clearly see the absolute directory reference on your screen. So you can, in absolute directory references, you can reference a directory name within the virtual directory system using an absolute directory reference. The absolute directory reference defines exactly where the directory is in the virtual directory structure, starting at the root. Think of the absolute directory reference as the full name for a directory. So with the absolute directory reference, there is no doubt as to exactly where you want to go. To move to a specific location in the file system using the absolute directory reference, you just specify the full path name in the cd command. So if you just want to check it, so again, let's go to the WSL. So here I am, yeah, we are in home directory of the root user. So let me enter into the virtual root virtual directory. Now you can see, so in a root virtual directory all those things are there. Now for example, if I want to move to uh, into user, so user, or for example into etc, and then to find passwd. So there are two ways. One is, now of course I am in root directory, root virtual directory. So if I use absolute, what I have to do is I have to take the complete path. So cd and then forward slash, all absolute directory reference starts with the forward slash that refers that represents the root virtual directory. Then I give etc. See, so now I'm in the etc. Now if I want to go to mm, temp directory, tmp temp directory, I have only two options. Either I get back to the root virtual directory and go, or from here I can use absolute directory and go. Directly I'm giving the full address of that. So cd and tmp. That's it. That's how you can use the complete absolute path to enter. That's called the absolute directory reference. Whereas, so here you can see, if you note that point, the tilde. So notice in the preceding example that the prompt originally had a tilde in it. So after the change to a new directory occurred, the tilde was replaced by user bin. This point I have explained it earlier, but I just want to uh, repeat it one more time so that it will be clear. So the tilde will has become changed into the forward slash tmp. So the absolute this happens because after the change to a new directory occurred, the tilde was replaced by forward slash tmp. This is where a CLI prompt can help you keep track of where you are in the home directory or virtual directory structure. The tilde indicates that your shell session is located in your home directory. Your shell session is located in the home directory. After you move out of your home directory, the absolute directory reference is shown in the prompt, if the prompt has been configured to do so. So then let's take one more example. That's the pwd command, and after that you have one more thing, that's uh, a relative. Next, using relative directory references. So the same thing we can do. This is what we have mentioned is absolute directory reference. You can do the same with the relative directory references. So this relative directory reference allows us, here what we do is a relative directory reference allow you to specify a destination directory reference relative to your current location. A relative directory reference does not start with a forward slash. This is the main distinction. So for example, let's get into that WSL first. So now I'm in temp. Okay, yes, yeah, I'm inside the temp. Now um, I have to go to the um, SRV, or I have to go to the bin. So how can I do that without using absolute directory? The first option is, so you have to get it. You have to get back to the root user from here, from here to root virtual directory. For the click on forward slash. Then let me check what all are there. Here I can find the bin or etc or home, everything. So I'll go to the home from here without giving forward slash. Okay, see, here I have three users. Again, without mentioning the complete absolute path, I am just writing only the directory name. So see, this is how you can use a relative directory uh, reference to navigate through your folders in your Linux system. So uh, let's do a few exercises before going into the um, another before going to the few more points. So let's clear it off everything, and WSL, yeah, let me clear it. Okay, so now let's type who am I. So I'm a root user, and then pwd is the command to find where you are, to locate you, to, it's like Google, to find out where is your location. So I am inside the uh, home and then Charan directory. So then let me check what all files it has. It has nothing, no files in it, it's completely empty. So now I just want to read, I want to use I want to read a file which is inside the etc. So I want to see OS, what OS it consists of. For that I want to use absolute absolute directory reference. So cat absolute starts with the forward slash, and then it is an etc, and then OS release. So this is what, this is how you can use absolute directory reference for most of the purposes. So pretty name Ubuntu 22.04.1 LTS, and then version, and this is all about the voice release of the voice release file consists of. So of course I'm a root user. Still, if you are not, you can just do the sudo I to become a root user. Okay. Now let's clear it up everything. So before before we do few more exercises, let's look into few more commands and few more arguments here. So the next thing for us is dot, the two special characters used for relative directory references. These are not used in absolute directory reference. Why? Because absolute directory reference, you give the full address, full location where you are or where you have to go or what you have to read there. So that's the reason. Whereas in a relative, it's relative to your location you are moving. It's a relative, it's not absolute. You are relatively moving from, you need a base, and based on that base you are moving. So that's the reason we have some special characters to use. The first one you can use, um, first one is dot, a single dot, the single dot to represent the current directory, whereas double dot to represent the parent directory. So let's move this here, and then where I am now, I am inside the root. I am a root now. So I'll, from here I'll use only. So now I want to get into TMP directory. How can I do? Oh no, I want to get into Charan directory. So for that, I have to get back to the root virtual directory. So without giving a name of the root, if you want to uh, go up a step, then cd space dot. So now you see where I'm a root user. So cd and then double dot. If you give a double dot, it will take you to the parent directory. So now you're in the root virtual directory. From here you have to enter into the home, so that that's where you can find your, see here you have Charan, so cd Charan. So this is how you use double dot and single dot to move across. cd and then put single dot, it will not it will keep you in the same directory. It won't move you into another directory, because this dot, single dot and double dot will use for the copy paste, this kind of purpose. And then we will look into the display listing, basic display listing. So here listing files and directories. To see what files are available on the system, use the list command, ls. Use the list command, ls. This section describes the ls command and options available to format the information it can display. Okay, so now display a basic listing, the simple one. So notice that ls command produces the listing in alphabetical order. If you are using a terminal emulator that supports color, the ls command may also show different types of entries in different colors. The ls colors environment variable controls this feature. And the basic ls command can be somewhat misleading. It shows the files and directories contained in the current directory, but not necessarily all of them. So Linux often uses hidden files to store configuration information. In Linux, hidden files are files with file names starting with a period dot. So these files don't appear in the default ls listing, thus they are called hidden files. Now the capital R parameter or option is another option that is that ls command can use, called the recursive option. It shows files that are contained within subdirectories in the current directory. If you have lots of subdirectories, this can be a quite a long listing. So here is a simple example what the R parameter produces. The F option was tagged onto the help you see the files. So let's uh, let's get into the cd using absolute directory to tmp. Okay, so now ls, so this emulator has a color, so that's the reason it has differentiated the files and then other directories. So if I give ls hyphen a, it will show hidden files also. That hidden files were shown in the green color, you can see the dot also. Now when I use ls R capital, so it's a recursive. Even the files which are inside those directories, are also being visible very clearly. So that's how these parameters, that's how these options help us a lot. And finally what we have is a long listing. So in the basic listings, the ls command doesn't produce much information about each file. For listing additional information, another popular parameter is L. The L parameter produces long listing format, providing more information about each file in the directory. The first line in the output shows the total number of blocks contained within the directory. After that, each line contains the following information about each file or directory. So let's use ls and then only l, the long list, and see what's going to happen. This is what is going to happen when you use a option. The file type, the first thing, the file type, such as a directory d. If it starts with D, it's a directory. If it is a file, it will starts with hyphen. So these are the files. File 3.txt is a file. That's why it has been started with the hyphen. Whereas tmp hyphen 5603 is a directory. It started with the D. And if it is a linked file, it will be started with the L, and character device C or block device B. Then after that, what we have after this first character, after that what we have is the file permissions. After that, the number of hard links. Here these are the number of this one is number of hard links. Then the owner username, this is the owner username. Root user is the owner of this. And after that, the file primary group name. So this root user belongs to this root group. And after that, the size of the file, and then month and year, and finally the last time when the file was modified. This is the time, the last time when the file was modified, and then the file name. These are the information will be given by one option that's called long listing option. This is very beneficial, so don't forget that you can also combine many of these parameters, many of these options together. You can often find a parameter combination or option combination that not only displays a desired output, but also is easy to remember, such as let's take up this thing, ls l capital R T and F. See everything. Okay, everything. I have to make it bigger. You can see clearly. So you have three directories, and then these are hidden. So you got the complete information. There's directories, and then everything. So this is how you can combine the options together too. So let's do the few more exercises. Let me clear it off completely. Let me clear it off, and let's begin. So for this exercise now, let us use cd and pw to navigate across our Ubuntu universe. So let's begin with who am I. I'm a root user in this, and then pwd, the present working directory, then ls command to get the listing or list of the files that are present in that present working directory. Then what we have, we'll use absolute directory reference to enter into bin. So bin consists of plenty of utilities. You can clearly see these are binary files, and after that let's clear it off, and then let's move to etc or sbin. It's just, I just want you to follow with me, and then just navigate across the Ubuntu system. So let's sbin. Sorry, that's my bad, sorry. So let me check. So these are the utilities that are present inside the sbin. Then let me clear the screen. Then after that I will go to the etc cd. All are for all commands. I'm using absolute directory reference. Let me see. There are a lot of files in even in etc also. So let me clear this screen again, and then this time I will go to the I'll directly use a absolute directory reference, and I want to read the host name of this file. Of course you can see the host name, but still I just want to check for that. etc and then host name. That's it. That's how uh, the same activity. The activity here is to uh, find out uh, find out the host name. Find out the host name. So for us, there are two options. The first option is using absolute directory reference. So for this, I'll use cat etc and then host name. That's it, the game over. And the second option is um, relative directory reference. So here what I have to do is cd, and then where I am, first I have to check. So I'm in etc. Fantastic. So in that case, let me yeah, I'm in etc anyway. That's okay. So here I can see the host name here. So I'll just cat host name. That's it. This is another way of doing the same activity. So let me clear it off the screen. Let me clear off the screen first, and then cd temp. This is absolute reference. There are a lot of files in it. Now let me go to the boot, and then okay, and boot. So now similarly, uh, I just want to see the grep file which is there in boot. Okay, so yes, okay, here in this file boot is completely empty. So now we will enter into the proc cd proc. So there are a lot of files in it. Key users, logs are very important. Modules, mounts, c groups, stats, swaps, uptime, version, and all of stuff. So let's ls, and let's clear it, and then type uptime. So when you type uptime, this will give you the uptime of your system for what time it has been up, and how many users that are using, average load, and then all details it's going to send. So now if you want to read that binary file of the uptime, so then proc and then uptime. So this is what you got it after doing the concatenation of the uptime file using that. Then you can use free and then m icon. So it will give you memory, about your memory. So how much is available and how much is used and how much is free and how much is shared, both memory and then swap memory. So both you'll get the free and then option M, so you'll get the memory. So clear it off. Then, and final thing is, I just want you to, one more time, I just want you to focus on seeking help from your Linux system, because that's very important. So how would you do that? Man and then command name. So it will give you complete information. Just go through it and then find out the what all options are beneficial for what kind of function. So you get it everything. So based on that, you can use it. So I will write different options. Okay, where we are in proc ls, yeah, this is how you get it. Ls option L, long list, you'll get it. Ls option R, this is a reverse direction, you'll get it. Ls time t, it will be sorted based on time. Ls lrt, with a combination of three options. Now let's look into linking files. Linking files is a great option available in the Linux file system. If you need to maintain two or more copies of the same file on the system, instead of having separate physical copies, you can use one physical copy and multiple virtual copies. This concept in Linux is known as links. Links. A link is a placeholder in a directory that points to the real location of the file. Two types of file links are available in the Linux system. First one is a symbolic link. First one is a symbolic link. A symbolic link is simply a physical file that points to another file somewhere in the virtual directory structure. The two symbolically linked together files do not share the same contents. And the second one that we have is hard link. Hard link. A hard link creates a separate virtual file that contains information about the original file and where to locate it. However, they are physically the same file. When you reference the hard link file, it's just as if you're referencing the original file. To create a hard link, again the original file must pre-exist, except that this time no parameter is needed on the ln command, that link command. So the most important point to be noted that you can only create a hard link between files on the same physical medium. To create a link between files under separate physical mediums, you must use a symbolic link. So let's demonstrate the same thing here. The links. So symbolic links are like desktop shortcuts we use in Windows. Okay. So let's take this example and we'll put it here. Let's clear it up. Let's create a directory mkdir p option parental, then opt, in the dev, in that ops, in that devops, in that test. and let's create this directory. Okay, now let's see. C D opt. Yes, you got dev and you got ops in it. You got everything in it. So now what will we do is we'll create a file. We'll create a file. We'll write a file in the same location. So opt and then dev, then ops, then devops, then test. In that we'll write commands dot txt. So that is what our file. Okay, so here, so we have written, we'll write some commands in it. Example, uptime is one command. Sys uptime ls pwd, and then who am I, say who am I, who, I think enough. So and then uh, time. Yeah, so these are some commands we have written. So let's save this. Okay, so that's where we have file. Now we have to so uh just a safety purpose, we want to have a shortcut of it. Okay, so we want to create a soft link or shortcut for the commands.txt, because we feel that's very important. That file is very important for us. So now what I have to do is to create a soft link. So ln is the command we have to use, and for the soft link I have to use s option. Then again same, the complete absolute directory reference that I have to give, opt dev, then ops, then devops, and inside the test, and then that's where I have commands dot txt. So now this file, we have given the object, we have given the absolute directory reference. The file which is there in the given absolute directory reference should be created a shortcut as the following. That should have the following shortcut, and the name of that would be commands shortcut. That's it. So let's see. Okay, sorry. Yes, you got the commands shortcut has been created, and now we will do the long listing to get whether it is soft, whether it is what type of file it is. We'll get to know. So it's clearly here, it is, it's a L. It's not the directory, it's not the file, it's a link. L, it started with the here you can see this part, it's a link, it's a link. And this command shortcut has been linked with the file which is there in this absolute directory reference. That's how we create a link. So then we'll see what is there in that. um, so let's see. Sorry, cat commands shortcut. See, whatever commands that we have given and we have written inside that file, commands.txt, the same thing is there in the say commands shortcut, because it's literally a shortcut of it. So this is how we create shortcuts, symbolic links. Here in Linux we call it as a symbolic link, whereas in Windows it's a shortcut. So now, so what will we do is we'll try to move this commands.txt to temp directory and see what's going to happen. So opt, again dev ops, and then devops test commands.txt. This is the file and want to move to tmp. Let's see. So the tmp, see, commands.txt has been moved. So now let's do lsl. Yes. So let's clear it up. Even though you move it, still you can the same shortcut has been existed. Now to delete the shortcut or soft link, uh, let's see how can we delete it. So we have to go to the, I think it's opt. Yes. So here we have okay, that's cd, and then opt cd dev. Yes, here we have commands that shortcut with a red color. So let's try to delete that. That's it, it's been deleted. So or else we'll create one more shortcut and we'll see. Okay, ln another symbolic link and opt dev ops devops test commands dot txt, sorry, txt with cmds. Okay, we got created two. Let's go to the commands cat. So no, it's just got created a soft link, but there is no file. Okay. So let's delete both cmds and then commands dot txt. Okay, what will we do is we'll create vim opt devops test commands dot txt. Who am I? Time, uptime, ls, pwd. I think this is more than enough. Okay, escape first, then colon, then enter. Okay, now we got it. Now we'll create a soft link, lns opt devops test commands.txt and link it. Yes, you got it in green color. So let's do the cat cmds. Yes, it's ready. Now let's try to delete it and see what's gonna happen. rm cmds, it's done, it's been deleted. Or if you want to unlink it, simply use the same command and unlink it. That's how it works. So now we will move on to the renaming and moving files. For that, what we are going to use, that's what in the Linux world, renaming files is called moving files. The mv command is available to move both files and directories to another location or a new name. Notice that moving the file changed the name from for example fall to fzll, but it kept the same uh, same data inside, number and timestamp value. So this is because MV affects only a file's name, not the property. So after, so now we can use even CP command. Uh, the CP, like CP command, you can use the I option on the MV command. Thus, you are asked before the command attempts to overwrite any pre-existing file. So let's uh, have a let's look into one practical example of renaming and moving files. To will begin with the rename the files. Okay, first we'll clear the screen. Okay, so now we'll rename the files using mv command. Okay, so first what will we do is we will write a file. Let's touch file1, and okay, so now in this directory you got file1, and then now I just want to rename that file1 to file2. Simple, file1 mv file1, and then rename it as a file2. That's it. Okay, if you still have a doubt, what we can do is we'll download, we'll get some lyrics. This is my AWS account. Okay, mm, let me download some lyrics. Kantara, yeah, here it is. Let me download, let me copy these lyrics from holagi .in. Then once we got our lyrics, let's paste it. Yeah, ಸಂಜೆಯ ಕೆನ್ನೆ ಮೇಲೆ ಬಂದು ನಾಟಿದೆ ನಾಚಿಕ ಮುಳ್ಳು. Okay, this is enough. So now let's vim singara I, and then paste it. That's it. Sorry, escape and wq. So this is your singara file. So this is what the lyrics that you have, and then let me check it. So the singara, so now the singara file, I want to change the name to kantara lyrics. Okay, kantara lyrics. So for that, what I have to do is mv, and singara is the file which I want to change, and to be changed into kantara lyrics. That's it. That's it. Let's see. Sorry, cat kantara. See, muddada mayangi, maunada sarangi, mohakamadangi, kanna hakide munguru lasoke. So that's how you rename it. Okay, now let me clear the screen again, and then now what will we do is to move the files used by mv command. Now we'll try to move these files from now we have seen how to rename it. Now we will move it from one directory to other directory. So now where I will put it, this is in opt dev, so I will put this in mm, in tmp. Okay, so where I am in opt and then div. So now I will put it in So for that, move and file name Kantara lyrics, and then location is tmp. That's it. So ls tmp, here it is, your Kantara lyrics. Got it? So this is how you move the file from one directory to other directory. If you have a doubt, we'll move into tmp, and then here we have all those files, and then get Kantara. Yes, got it. Now, so next we will move into deleting files. How do we delete the files? So for that, to deleting the directories or deleting files, basically everything in Linux is a file. That's how Linux kernel looks into it. So most likely at some point you will want to be able to delete existing files, whether it is to clean up a file system or to remove a software package. You always have opportunities to delete files. So the command that we use to delete the files is rm. So rm, and then I option, the I option parameter prompts you to make sure that you are serious about removing the files. Then of course, remove, if you want to remove all the files which with uh, starts with f and ends with all kinds of four words, a pattern, so it removes. These are the different ways of doing deleting. So now what will we do is we go to the our WSL, and we will delete some files, and we'll see how it goes. So again we can, so here we have a lot of files in it: file 1, file 2, file 3, file 4, jenkins.pub, Kantara lyrics, script, everything. So now what will we do is we will delete the files one by one. Okay. um, to delete the files, we have to use rm. First, rm file 3.txt. That's it, it got deleted. So but the another way of doing is commands.txt. So it's asking, that's what interactive, that I option will make your deletion process interactive. So now I will, so it's asking rm regular file commands.txt. So that's it, now it got deleted. So that's how we use an interactive process to delete the files. Now we have 3 files there. Let me touch uh, file fuzz.txt. Let's see. So now I want to delete all the files with the following pattern: le.txt. No such file. That's it. Only one file is there with that pattern. Of course there's a question mark, but z is there. So all the files with that pattern got deleted. Okay. So this is how we use rm command to delete. If you still want to uh, explore rm, you can do man rm. So then it will give you the complete information about rm command, and what all options are available. Example, I option prompt before every removal. So like this, you can get it all. Option D, remove empty directories. This is how it helps. Okay, so now let's look into managing directories. Now it's time managing directories. Linux has a few commands that work for both files and directories, such as the cp command, and some that work only for directories. To create a new directory, you need to use a specific command, which is covered in this following three sections. Removing directories can get interesting, so that's also covered in the following section. So let's begin with creating directories. Creating a new directory in Linux is easy. Just use the mkdir command. So the system creates a new directory named dir. Notice in the new directories long listing that the directories record begins with a D. This indicates that new dir is not a file but a directory. You can create a directories and subdirectories in bulk if needed. However, if you attempt this with just the mkdir command, you get the following error message. So to create several directories and subdirectories at the same time, you need to add the p parameter. Okay, that we will test it now. We will check it and see. Let's go to the WSL again, and this time we will place this on left side of my screen. Yeah, it's fine. Yeah, then let me clear it off. Now let me call mkdir. Yes, this is how it works. So enough is enough. You can cross check it. Adding out of that man. So now let me create a directory first. Let me enter into the cd. There are a lot of files in it, and directories also. Here I want to create one directory with try try mkdir. So that's what the name of my directory. Let's see, that's what it got created. We'll test it with the long listing. Try mkdir is a directory. That's it, it's a directory. Now clear it off, then ls pwd present working directory, then create one more directory, that's mkdir directory 1. So now you can create two directories at a time, three directories at a time. Ops is one, devs ops is one, and then ml is one, ai is one. That's it. See, ai, dir one, ops, ml, all three directories are created at a time, were created at a time. So now I'll create now I'll touch a file, test file 1.txt, and then that is clearly a file. That's it, it's a file, it's not a directory. And one more thing that I want to show you is magical stuff. So if you want to create multiple files at a time, So what we can do is touch DevOps file and then curly braces 1 double dot 10 and then close curly braces dot txt. So now this is our pattern, and then with this pattern 10 files are going to be created. Let's see the magic. Here it is, from DevOps file 1 till 10, lslrt, from 1 till 10. That's how it works. So now what I will do is, let's enter into the dev and then copy this file into that DevOps file 1.txt into dir1. So we have a lot of directories here. So I have this DevOps file 1.txt, and that should be copied into ops. So let me copy and dev file 1.txt into ops. So let us go into the ops and see it got copied. So then similarly go to the ls, go to that and then check. So now what we will do is, we will move all .txt files which are there. Where have been, sorry, ls, okay, pwd. Let me get back one step behind, one step. Then okay, I have a lot of .txt files, so I want to copy all these .txt files into dir1. Let's see how can we do it. So copy, or I'll move, and then asterisk .txt and put it into dir1. All gone, vanished. Then where are they? Let's go into the dir1. That's it. Magical. Brilliant. Yeah, that's how it works. That's our Linux. So now this is how we have created files and manipulated the files names and moved across, and created directories. So now we will try to create a parental directory. For that, for example, I'll get back to one level up, and then here I will create one parental directory. For that, what we have to do is, uh, we have to use p option, and then like it's my YouTube channel. In the DevOps is the DevOps course. In that presently I am working on Linux course, and in that I am working on rudimentary basic commands, basics, and then commands. Let's see. Yes, that's how you create a uh, parental directories. So now where is my like okay, ls okay, got it. So cd, I think it's somewhere, yeah, here it is. So here is like. So now let us do recursive. See, you can see in one go Imlike consists of DevOps consists of Linux consists of basic consists of commands. That's what we have created. So this is how you can manipulate, and we can create different directories using mkdir. So then we will look into deleting directories. So removing directories can be tricky, and for good reason. There are lots of opportunities for bad things to happen. When you start deleting directories, the shell tries to protect us from accidental catastrophes as much as possible. The basic command for removing a directory is rmdir. rmdir. So by default, the rmdir command works only for removing empty directories, because we created a file, mv.file, in the new directory. So the rmdir command refuses to remove it. To fix this, we must remove the file first, then only we can use the rmdir command on the empty directory. So let's test it. I think let me go to the mlike only. Okay, so here I have DevOps, and then in DevOps I'll create Linux I have, but still I'll create one more. I think basics Linux, and okay, here I'll create a file, no, or else mkdir rmdir basic. The file, it is failed to remove because the directory is not empty. So that's what I want to prove. So if directory is not empty, so but what is there inside that? So ls basic, it consists of commands, and then we will move into the commands. Okay, okay, commands is empty, so we should able to delete that commands option. So let's get back to the one level up. Then so we have commands in it, it's completely empty, we should able to delete that. That's it, it got deleted. So if there is a file in it, we will not be able to delete it. If there is no file, we can delete it. Anyway, let's get back 2 steps down. Okay, now we are in Linux, so I'll try to delete normally with Linux. We are unable to delete it, but I will use a different method, that is ri linux. So simply just that will prove that if there is a file or a directory within uh, in a directory, then it's very difficult to delete it. It's impossible to delete it. So that's how deletion of directories work. So you can also use the rm command on entire non-empty directories. Using the r option allows the command to descend into the directory, removing the files and then removing the directory itself. So here rm dir, and then r option, and or simply rm or that's it, it got deleted. So this is another way of deleting. Either you can use rmdir or simply use rm with the rf, that's a recursive, and then Linux. So let's get into the root virtual directory. So we'll uh, directly delete imlike without any option, and we'll see whether it's possible or not. It is impossible because this imlike directory is not empty. So to delete it, the option that we have is rm and rf, that's a recursive, and then force it to delete, and then imlike. That's it, gone. Imlike is gone. So this is how deletion, moving, renaming, copying, and creating linking of the files takes place. The ultimate solution for throwing caution to the wind and removing an entire directory contents and all is the rm command with both the R option and F option. So the RM command with RF option gives no warnings and no fanfare. This, of course, is an extremely dangerous tool to have, especially if you have super user privileges. Use it sparingly and only after triple checking to make sure that you are doing exactly what you want to do. So I think we have used RMRF in our previous exercise, but still, if you have it out, we'll directly get into the temp. So here, if you are unable to delete some file, you can directly use rm and force it and recursively that file 4.txt, and then you can delete it. That's how an rm and rf works. So now we will move on to viewing the file type. So you can use several commands for looking inside files without having to pull out a text editor utility later in this course. So this section demonstrates a few of the commands you have available to help you examine files. The first one is viewing the file type. Before you go charging of trying to display a file, try to get a handle on what type of file it is. If you try to display a binary file, you get lots of gibberish on your monitor, and may even lock up your terminal emulator. So the file command is a handy little utility to have around. It can peek inside of a file and determine just what kind of file it is. This following example, you can see that file my script, file new dir, file my file. So this example shows a file that is a simply a directory. That file new dir is a directory. Thus the file command gives you another method to distinguish a directory. Now the following example shows the what the file command returns for a script file. When you type file and then my script, although the the response that is returned is the file is ASCII text because it's a script file. You can execute run it on the system. And the final example is a binary executable program. The file command determines the platform that the program was compiled for and what types of libraries it requires. This is an especially handy feature if you have a binary executable program from an unknown source. So let's jump into the Ubuntu version, Ubuntu distribution Ubuntu shell, and then let's start working on that. Let's create a okay, here I'll create mkdir testdir first, and then let me touch it file.txt. So, and I'll write vim code.py. That's x is equals to 1, y is equals to 2, and z is equals to x plus y, and print z. So this is our Python script. Then, and test there. So now let's start checking one by one. So we have different types of files here. So let's check what is file type of test dir. It's clear, it's test dir directory. It's test dir directory. Next, let me clear it off and then check file type of okay, ls file type of script.sh. It's clearly given script.sh is Borny against shell, that is bash. Borny against shell is called as, in shortcut, it's a bash script ASCII text executable. Then let me check what type of file is our Python script. That's code.py. Just a minute. Code.py. So it's a code.py and ASCII text. Then what type is our bin and ls? So it's clearly a detailed explanation. Bin ls is a utility. It elf 64-bit lsp pi executable x86 version 1 dynamically linked. So that's how a file command is useful. Then what we have for us is viewing the whole file type. What are the content? Viewing the contents of the file type. If you have a large text file on your hands, you may want to be able to see what's inside of it. Linux has 3 different commands that can help you uh, here, using the first one, using the cat command. So the cat command is a handy tool for displaying all the data inside a text file. So if you use the n parameter or n option, it numbers all the lines for you, and the feature will come in handy when you are examining scripts. If you just want to number the lines that you have text in them, then b parameter is for you. So finally, if you don't want tab characters to appear, use the t parameter. So what will we do is, I think here it is Kantara lyrics. So we will try to view the content in the Kantara lyrics. How can we do that? Using cat. So that will show you all the lines, all the complete contents in it. Okay. So that's one way, or we can use some options with it. Cat, and then n number the lines, and then Kantara lyrics. See, each line has been numbered. So total 28 lines of data is present in that. Of course, few are empty spaces, but that is also considered as data. So, and we can use one more option, that's cat, and then option B and Kantara lyrics. Yes, this time also worked. So this is how a viewing of the whole file can be done. So then we will look into more commands. The main drawback of the cat command is that you can't control what is happening after you start it. To solve the problem, developers created the more command. The more command displays a text file but stops after it displays each page of data. We typed the command more and then uh, to produce a sample more screen. Similarly, we can use a less command. Using the less command, from its name it sounds like it should not be as advanced as the more command. However, the less command name is actually a play on words and is an advanced version of the more command. The less command name comes from the phrase less is more, so it provides several very handy features for scrolling both forward and backward through a text file, as always as some pretty advanced searching capabilities. So let's use these commands, and then okay, so now this is using more and less command. For more it's more and then etc bash.bash rc. That's it. See, this is how it works. So now more 30% is still left. Then scroll down. Here we have 58%, 83%, only 17% is left. Now all is visible. So that is how it is useful in showing. Similarly, less, just a minute, the same command and then less. Okay, I think it's not there with it. Okay, so now we will look into viewing parts of a file instead of looking into complete content of the file or whole file. So we will focus on how to view parts of a file. So often the data you want to view is located either right at the top or buried at the bottom of a text file. If the information is at the top of a large file, you still need to wait for the cat or more commands to load the entire file before you can view it. If the information is located at the bottom of a file, such as a log file, you need to wade through thousands of lines of text just to get to the last few entries. Fortunately, Linux has specialized commands to solve both of these problems. So the first one is tail, using the tail command. So the tail command displays the last lines in a file. Uh, uh, by default, it shows the last 10 lines in the file. So you can change the number of lines shown using a tail by including the n parameter. In this example, only the last two lines of the files are displayed. If you by adding 2 to the tail command. Now what else we have is head command, using the head command. So The head command does what you would expect. It displays a file's first group of lines. The file's head, by default, it displays the first 10 lines of text. Similar to the tail command, the head command uh, that command supports the n parameters, so you can alter what is displayed. So both commands also allow you to simply type a dash along with the number of lines uh, to display uh, to display as shown below. So what will we do is, let's open this, and then now we will reduce the width of our shell and increase the length of our shell, and rest all will keep it, and then ls. uh, okay, okay, it has a huge stuff. Okay, let me get into cd opt. That would be fine. Yeah, and now clear it off everything. So now I want to see cd var log. I want to enter into the var log. So I have few files in it, out of which I want to check, out of which I want to cat dpkg.log. Oh, there is a huge amount of stuff in it. So it has a huge amount of stuff. I don't like to print all the lines of dpkg.log file into the screen. So I would go for tail first. So tail dpkg.log. Okay, tail dpkg.log. So approximately 10 lines were printed. These are the last 10 lines. So we can do another way, that tail and then put an option, that is an option for the number, and only 2 lines we just want to print, and then dpkg dot log is our file. Yes, that's it. Only 2 lines, the last 2 lines were printed. And similarly we can use head and dpkg head.log. So it has printed only 10. See, here it is, and from here to here only 10. So now we can use the same number option to do the same. So head and then 5 directly, then dpkg.log. Yes, it is. It has printed only 5. This is how the cat file, basically cat more less tail head and n options help us in viewing the files. Let's look into more commands now. The unmount command to remove a removable device. You should never just remove it from the system. Instead, you should always unmount it first. uh, this unmount command gives you the choice of defining the media device by either its device location or its mounted directory name. If any program has a file open on a device, the system won't let you unmount it. And this, and similarly you can do the same. So you use unmount command and then directory or device. So that will unmount the image file or whatever is there successfully. Then using the df command, sometimes you need to see how much disk space is available on an individual device. So the df command allows you to easily see what is happening on all the mounted disks. The df command shows each mounted file system that contains data. As you can see from the mount command earlier, some mounted devices are used for internal system purposes. The command displays normally this command displays if huge amount very important data that we are going to see ahead. And in addition to this, we can use options also. If we use h option with the df command, this together shows the disk space in human readable form, usually as an m for megabytes or a g for gigabytes. So let's get into the wsl and mm, let me clear it off and now cd opt no cd tmp. So here we have files, but when you do ls the listing, you can see only file names. If you go for long listing, you can see permissions and everything together with the file. But what we want to see is the size of the files. For that we have to use df command. So for that I'll use df. Here it is. So basically it has given some information. First one is the device location, and then 1k blocks. These are 1k blocks. 1k block means that's 1024 byte blocks of data it can hold. So how many 1024 byte, that is 1k blocks of data it can hold. Then how many 1024, that's a 1k byte blocks are used, and how many 1024 byte blocks are available. So this is what 1k blocks of data it can hold, it used and available. So that's the data here we can see. And the final one is the amount of used space on percentage. That's a use percentage, the amount 1% in this mounted space forward slash mnt forward slash ws. Only 1% of space has been used, and remaining is available. See, this much of 1k blocks can be hold, and 4 blocks are used, and this much is available. In percentage it's 1%, and then mounted on forward slash mount wsl. And the last one is the mount point where the device is mounted. This is the place here, the device where the device has been mounted. You can see for all others also. For drivers, dev sdc, it's 1%. Then wslg init run everywhere. There is not much of uses other than drivers. For drivers, almost 87% of usage we can see. Okay, so next what will we do is we will using we'll use df option, and we'll see. So here it is, just for your reference, your understanding. So df report file system. What df does is it's a report file system disk space usage, and this is how the syntax of this df command looks like. Df and then option, and then argument if it is any, and then you can have plenty of options. Let's look into one option first, that is small h. uh, it is human readable. Print sizes in powers of 1024, for example 1023 megabytes, MBs or KB or GBs or TBs. So let's do it and see what's going to happen. DF and H, that is human readable format. Here it is. So in spite of measuring it in blocks, we can clearly see 3.8 GB is the size, out of which 4.0 KB was used and the 3.8 GB is available. So usage percentage is 1% and mounted on /MNT whereas drivers 137 GB used 119 GB, available 19 GB. So 87% of this driver's mounting point has been used. So this is how it's useful in finding the size of our spaces. Then we will move on to using du command. With the df command, you can easily see when a disk is running out of space. The next problem for the system administrator is to know what to do when that happens. So with the df command, you can easily see when a disk is running out of space. But after you got to know, okay, this disk is running out of space, then what you have to do? So here we'll use by default the du command displays all the files, directories and subdirectories under the current directory, and it shows how many disk blocks each file or directory takes. For a standard sized directory, this can be a quite a listing. Here is a partial listing of using du commands. So a few options that would help us uh, using this du command better, or in other way it enhances the functionality of du command. If you see, it produces a grand total of all the files listed, and if you use -h, that's option H, it prints sizes in human readable form using K for kilobyte, M for megabyte and G for gigabyte. So let's get into the WSL one more time and we'll check it. Okay, so let me clear it off all those things, and then let's give it a du command first, and let's see what's going to happen. This is how it gives, but of course it is not that human readable. uh, uh, we can't make much sense of much we can't make much sense out of it. So what will we do is we'll use some options. DUH option, that's a human readable format, that's how. So we are in temp and these are the directories it consists of. These are the directories it consists of. Test directory has 4 KB, 4 KB, 8 KB, 9, 2 KB. So these are all not that bigger, and total space is 132 KB. So we will explore documentation once. So this is how you go into the documentation, and we'll see what is C. C is produce a grand total, and then what we have is B. B is a block size altogether. So let's get back and we'll apply options one by one. So first option, we have applied the human readable format. That's fantastic. Then we'll go for C. So it will give you the total. This total, of course we'll get it, but it will mention that total space is used by the directories and folders. Then we'll go for DUCH, that is C and a combined one. So C and human are readable. Okay, so now everything has become so you got the total as well as human readable format. Then we'll go for another option, that's B option. So the B option requires an argument, that's okay. So then that's how a du command help us finding the total size used, total memory used by the different directories or folders or files in that directory. Then we will move on to the working with the data files. So when you have a large amount of data, handling the information and making it useful can be difficult. As you saw with the du command in the previous section, it is easy to get data overload when working with the system commands. So the sort command is a popular function that comes in handy when working with large amounts of data. The sort command does what it says. It sorts data. So next we will look into how to work with data files. So when you have a large amount of data, handling the information and making it useful can be difficult. As you saw with the du command in the previous section, it is easy to get data overload when working with system commands. So let's begin with the sort command. It is a popular function that comes in handy when working with large amounts of data. The sort command does what it says. It sorts data. So by default, the sort command sorts the data lines in a text file using the standard sorting rules for the language you specify as the default for the session. So if you are expecting the numbers to sort in numerical order, you were disappointed by default. So the sort command interprets numbers as characters and performs a standard character sort, producing output that might not be what you want. To solve this problem, use the n option or hyphen n parameter, which tells the sort command to recognize a number as numbers instead of characters to sort them based on their numerical values. If you use the m capital M option or hyphen capital M parameter, the sort command recognizes the three character month nomenclature and sorts appropriately. So here what will we do is we'll place it here and we will try some examples here. So let me check what all files are there. File 5.txt. Let's write vim and then file1.txt. So I'll get some data. mm, okay, just a minute. Yeah. mm, Let me get this data and copy it into here. Okay, it's done. Escape colon WQ. Okay, your file is ready. So what I will do is, in addition to the things that we have copied into that, we'll also, or else we'll use cat and see what is there in that file. Yes, so it's about the sound of worm. And now let's do the sort an option and then file1.txt. So it's, there is not much of difference, whereas if you see in another way, we'll use sort and capital M file1.txt. So, okay, so what will we do is, instead of using these paragraphs, copy etc passwd and file1.txt. So let's do the cat now. File1. Yeah, so now let's sort it, and file1.txt and using M. So these got sorted based on mm, based on the numbering, not based on randomly. So because the root should be at the beginning, but now the things have changed. Normally the Charan, Surya Charan, the normal users should be at the end, but things have changed a lot. So that's what I'm saying. So even here with the M. Okay, so that's how we use sort. So now we will moving on to the most important utility. The most important utility and widely used utility of Linux is grep, and this is basically searching for data. So often in a large file, you must look for a specific line of data buried somewhere in the middle of the file. Instead of manually scrolling through the entire file, you can let the grep command search for you. The command line format for the grep command is, you can clearly see on the screen. So the grep command searches either the input or the file you specify for lines that contain characters that match the specified pattern. So the output from the grep is the first lines that contain the matching pattern. And we have plenty of options that come along with the grep, and we are going to look into them one by one while doing some exercises. So here, grep3 file1 that searches the file 1 for text matching pattern 3. or if you go for the V option if you want to reverse the search, and you go for the N option if you need to find the line numbers where the matching patterns are found using the N parameter. So this is how it works. So let's jump into the some practical exercises, and then we will do it one by one. So let's begin. We are in, yeah, let me bring it, make it, yeah, let me clear it, let me clear the screen. So let me check listing and then clear it, and so let's go to the etc list it. Now ls lrt long listing, so it's clear there are a lot of directories and lot of files. Wait, 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 yeah, there are, these are all files, the white ones, these are all directories, so everything we can see. So now what I want to do is I want to grep, i I want to grep Surya from passwd file. Let's see. That's it. That's it. The line which consists of Surya, that line has been gripped. That line has been filtered. That line has been searched. Now I will grip Charan, just Charan in same passwd file. That's it. Now you got the two lines which has a Charan. This is a pattern matching, so which has a Charan. So let me clear the screen again, and let's do more. So let's grip uh, version. This is version from OS release. That's it. This OS release file consists of three version lines, and all three were printed on the screen. So let's see cron tab. Yes, so this is what the cron tab or cron time we are going to use in Jenkins, and even some other in job scheduler for the postman also. But it would be widely useful in Jenkins at that time we can see. But if you want to, you can have a look here. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then time 0 to 59 hours, 0 to 23, day of month 1 to 31, month 1 to 12. So 1 is Jan, 2 is Feb, and day of week is 0 to 6. That's it. Or Sunday is 0, and Sunday either 0 or 7 you can use. Okay, that's how. So we will do it. How can we use it in Jenkins to run your jobs at a particular time or continuously for a few hours in few days in a month or in a year. So that we will do it. But same procedure is followed here also. So this is a cron tab. This is a cron tab. So and we'll cat the group file too. Yes, this is group file. Here all the groups names are mentioned with their passwords. It is encrypted with X, and then group IDs, group username and then ID. So then what will we do is we will grip uh, Surya from the group file. That's it. See, this Surya, this group file consists of almost these many lines. Okay. Then we'll cat lsb release and see. Okay, lsb release consists of the following information. It's about the Ubuntu version, and then release and Ubuntu description. So out of this, uh, I want to grep di distribution release in from LSB release. Yeah, that's it. The distribution release is 22.04, the latest one. Fantastic. So then let me clear it off everything, and then ls. So clear it again. Cat nss switch.conf. So this it's a configuration file. uh, this consists of information regarding function example configuration of GNU name service switch functionality. So from this, what do you want to net group ether services, these are all DB files, whereas hosts and networks are files DNS, and password are, and group is file system empty. Okay, so now what I want to grep from this file is grep, and then I so I want to grep hosts. I want to grep hosts from ns switch.conf. That's it. Hosts is files DNS. Hosts is files DNS. So now let me do cat of shadow file. So shadow file consists of all the passwords which are encrypted. Here it is not directly you will get it. These are encrypted, and you have to decrypt that password to get your actual password. So now I want to grep the password for Surya, and a shadow is the file. That's it. So for Surya Charan user, and this is the password till this part, and then after that these are the different numbers. So that's how you can use it. Even I want to grep for the password of Charan from the shadow file. That's it. So this from here till here, this is your password. You just decrypt it, uh, and these are all encrypted. You just decrypt it, and you'll get your password. And let me clear the screen. Let's do the cat time zone. So it is Asia Calcutta. That's our time zone. I'm just doing it for fun. So now let me click history. So these are the commands that I have used. Kindly go through it and try it few more times. Okay, so before we jump into the another utility or command, I would like to throw you more exercises for you so that it would be much clearer. So I'm an etc, so I'll try to find network manager in this. Yes, now I'm listing out. It has two ls long listing I will do. So it has two files in it. One is a normal .config file, and the other one, and then other one is a directory, that's dispatcher.d. So now in this I want to vim network.conf. So of course it has nothing in it, so let me close it. I just want to see, but let me close it, and then cd goes one step up, and then ls. So a lot of files are there, out of which I want to enter into Linux directory. So let me check what all files are there in Linux directory. So what I found out of Linux directory is conf. That's cmanage.conf. So let me try to cat it. So there is huge amount of information, the policy version, next span check, and a lot of information it has. So out of it, I want to grep I see Linux from etc. Let's see what's going to happen. Okay, etc is a directory, so you can't grep it. So then what you can do is grep I linux and then etc and then capital R. That's it. This is what I want to show you here. So you can grep a directory using uh, R option. R option. So then it will give you complete information how many times and how many policies if it has a .config file, and how many times that C Linux word is used, that pattern is used in different lines of different files. Everything you get from it. So it's like if you want to search something, some file or something in a directory, you can do it using this command, grep and I and that pattern, and then the directory where you want to search, and then a capital R option. Okay, so let me clear the screen first, and then let's do more greps. So grep again, capital now C Linux, and then same etc and then R option. So now you got some binary file matches, only from binary file matches, so that can be shown. It's showing like this. Then clear the screen again. So now again grep now, but this time I'll put the R option ahead, and then Linux, that is capital, then etc and all again. A result is same. Either way you can do it. So let's vim etc Linux and then config. Okay, this is some information, that is cmanage.config the file we have here. So okay, so now what I have to do is I have to forcibly quit. Okay, yeah, let me clear it. So now what will we do is we will do few more activities in the same exercise. Let me do cd, let me clear it, and let me cat etc passwd. Okay, this is the information that we get it from the passwd that we have discussed earlier. So now just clear the screen and then check for cut, and then d, and then f1 etc passwd. That's it. So this is how you get the result, because you have seen the information in the passwd file, but I just want to cut it into words, each words. And how I wanted to cut it based on this colon. So this like segregating and separating and dividing the words based on the colon, so colon is a delimiter. So colon is a delimiter. So based on this delimiter and separate the each word. So all words which are present inside the passwd, which are different, which are separated by the colon, has been separated into individual words that you can see from top. Let me do it again. Yeah. So that's how it helpful. So clear. Okay, just a minute. Clear. Then again we'll do the cut, then D option with the colon, the delimiter, then hyphen, another option F3, then etc passwd. We are using the same file. So this time we got only the third one from the each line. The third one, what is the third one? Initially we got the first one, now we got the only the third one. Okay, if you have a doubt, let me go to the cat etc passwd file. See here, this the name is, the username is the first one, then the password, then user id, then group id, then again this is one information of the user, and then user's home address, and then finally user's shell. Okay, so now in first case what I did is, cut is our command, and delimiter option with the colon, but you get only the first item of the each line of the passwd. So you got it. These are all usernames. These are all usernames. Whereas in second case, what I did is, I want only the third one. That's the user IDs. I want only third one. That's user IDs. These are all our user IDs. And final one, we'll go for the group IDs. For that, nothing much to do. Just change the F4. That's it. These are all group IDs. Now, if you want to see the home address of each users, just go for F6. See, home Charan, home test, home Surya Charan Teja. These are all home addresses of users. And similarly other users which are present, these are not normal users, these are applications or services. They will also have their own home addresses. Okay, this is how this cut is helpful. Cut. Then after cut, we'll use awk awk, and I'll see how it can be beneficial. Let me execute the command first, and then we will talk about so awk, and then print $1 and close. Then again etc passwd. That's it. So now we will use an option to do the same thing. In spite of without option, let's put an option, that is capital F, and let's execute and see. So now from the passwd, it's taking time. Okay, let me control C it and then close it off. So ls, clear it off. Then we'll create some sample text, sample files, vm vim sample file dot txt, and then paste the same information as before. Okay, then close it, and cat sample file dot txt, and now what will we do is, out of which I want to filter some pattern. Okay, what is that pattern? It's not that huge data, so this time we'll go for the some corona data. Let's randomly get the corona data. Coronavirus Wikipedia. Yeah, so let's yeah, we got the huge amount of data now. Again, vim sample file.txt, and then okay. Yeah, vim sample file.txt. Okay, so we got it. Now let me close it, and now we want to filter a certain pattern of lines or sentences. For that we have to use sed. The command is sed, so let me close it. Man sed. So sed is a stream editor for filtering and transforming text. So sed, then you can have option, then script only if no other script, then input file. So this is, and sed, so you have some options here. So e for script, and I is important for us. I, this is as a suffix. So in place, so edit files in place. When you use an I option, it means edit files in place and makes backup if suffix has been put. So that's how we can use. Now sed, and let's take a string of pattern, that is S and corona virus or COVID-19, whichever, sorry, COVID-19, and then G. Let's see what's gonna happen, and then sample file.txt. That's it. This many of lines are there with that kind of information. So we will ask for only, or um, okay, China. The SED, okay, we're missing in place. Let's go for the SED I. Now we'll go with the I option, and sample file.txt. Now, and one more thing that we're going to check is SED and I option start with S, and inside you will have your data, that's COVID-19, then nothing, then it should be closed with G again, and then sample file 1.txt. So I think there is not such information, so let's put only one in place, that's China as command. Okay, that's fantastic. So this is how the SED is useful for us. And finally cat sample 1.txt. Okay, and let's clear it off. This slide digs into the Linux system management commands, showing uh, showing you to how to peek inside your Linux system using command line commands. After that, we show you a few handy commands that you can use to work with data files on the system. So let's begin with peeking at the processes. When a program runs on the system, It is referred to as a process. To examine these processes, you need to become familiar with the ps command. The Swiss Army knife of unities, so it can produce lots of information about all the programs running on your system. So unfortunately, with this robustness comes complexity in the form of numerous parameters, making the ps command probably one of the most difficult commands to master. So most system administrators find a subset of these parameters that provide the information they want, and they stick with using only those. That said, however, the basic ps commands doesn't really provide all that much information. So let us go here and uh, move it to the right side of your screen. Then let me clear it off. ls clear. So let me give ps. So this is what a ps do. PS will give you PID, TTY, time, CMT. Okay, so before that, let's go for the man PS. So name of the command is PS. What it does, it report a snapshot of the current processes that are running in that shell. And how do you use it? A PS command, and then options after that. And description, ps displays information about a selection of the active processes. If you want a repetitive update of the selection and the displayed information, use top instead. Top is one more. Okay, so this is how you'll get the complete information, and what all information you get, that also is mentioned here. Anyway, we'll go through it in slides, and these are some of the examples: pse, psef, pse capital F. These are widely used. psex, anyway we are going to use them too. So these are, and some of the options which are explained here. So let me get out of this manual, and then let's look into. So in this the basic output shows, just a minute. The basic output shows, the basic output shows the process id. That's the PID, the first one of the programs. Then TTY, this is the terminal TTY that are running from PTS. Okay, and then CPU time, this is CPU time the process has used, and this is the command that has been running. Bash is the bash shell command, and then PS is the process command. So now we can try some examples. Basically, that's PSEF. These are two options combined together. So if you need to see everything running on the system, use the EF parameter combination, or EF option, short option. So the E option which shows all the processes running on the system, and the F option which expands the output to show a few useful columns of information. And we will see some of the most important components of this PS. UID, this is the user ID, so the user responsible for launching the process. And PID, this is the process ID, the process ID of the process. And PPID, this is the PID of the parent process. It's a parent process ID if a process is started by another process. And capital C, this is a processor utilization over the lifetime of the process. And S time, the system time when the process started. And T, This is the terminal device from which the process was launched, and time, the cumulative CPU time required to run the process, and finally CMD, the name of the program that was started. So you can use the L option also. You can use the L option, which produces the long format output. So let's get back to our WSL, a nice Ubuntu one. And um, before that, okay, anyway, so before we jump into that one point, I just want to discuss is PSEF. We have discussed if you need to see everything running on the system, so that time we use this, and then L parameter also we have discussed. So now let's jump into the uh, okay, so here what will we do is man ps is done. Let me clear the screen now. So let's do pse and see. Okay, here you got all the processes which were which were and are there in your shell. Okay, so initially init, these are the four processes init, and then they were killed automatically, they were stopped, and then presently the running processes are bash and ps. That's it. So, and if you use ps and then f option, so it will extend and you will get complete UID, PID, PPID, C, STEM, TTY, time, CMD, everything as complete information. You can use both PS and then EF option to get the all information, all the processes, as well as the extended mode. You can do the PSL, the long listing of this, and you'll get the lot of information. Too much information will be killing. Okay, let's clear the screen, and let's move into um, a kill command. So the kill command allows you to send signals uh, to processes based on their process ID, a PID. By default, the kill command sends a term signal to all the PIDs listed on the command line. So unfortunately, you can only use the process PID instead of its command name, making the kill command difficult to use sometimes. So we also have a kill all command. The kill all command is a powerful way to stop processes by using their names rather than a PID numbers. The kill all command allows you to use a wildcard characters as well, as making it a very useful tool when you have any system that's gone away. Okay, so what will we do is we'll do the ps, and then we'll try to kill some. So ps and using PID, so kill 9. Okay, 407. So no such process, this has been killed. Then kill 9, that's it. Yes. So okay, this is how you can use it, or you can just say kill all and http if there is a service. Of course we do not have that service, but you can use the kill all to kill services also. So this is how you can use kill and kill all. Okay, that's okay. So now we will move on to the mount command. Here the mount media. So for the mount command, what we'll do is, as discussed earlier in this course, the Linux file system combines all media disks into a single virtual directory. Before you can use a new media disk on your system, you must place it in the virtual directory. This task is called mounting. So in today's graphical desktop world, most Linux distributions have the ability to automatically mount specific types of removable disk or removable media. A removable media device is a medium that can be easily removed from the PC, such as CD-ROMs, USB memory sticks. USB memory sticks. If you are not using a distribution that automatically mounts and unmounts removable media, you have to do it yourself. So this small section describes the Linux command line commands to help you manage your removable media devices. So that begins with the mount command. Oddly enough, the command used to mount media is called mount, M-O-U-N-T. By default, the mount command displays a list of media devices currently mounted on the system. So the mount command provides four pieces of information. The first one is the the first one is there's a huge stuff here. The first information, you just go through it. The first piece of information that it provides is the device file name of the media that you can see here. Then the mount point in the virtual directory where the media is mounted, so then you will see the mount point. And then finally the file system type, here it is, here it is, here it is. And the access status of the mount media, the access status of the mount media, and inside that you will have a lot of other information. Uh, that's a lot of information. And the type parameter defines the file system type under which the disk was formatted. Linux recognizes lots of different file system types. If you share removable media devices with your Windows PC, you're most likely to run into these types, either VFAT, that's a Windows long file system, or NTFS, that is Windows Advanced File System used in Windows NT, XP and Vista, or ISO 9660, the standard CD-ROM file system. So most probably, yeah, so this is how a mount helps, and then you can use some options with that based on the type. So mount T option, and you can mention the type and device directory also. And after a media device is mounted in the virtual directory, the root user has the full access to the device, but access by other users is restricted. So now most USB memory sticks and floppies are formatted using the VFAT file system. So if you need to mount a data CD, you must use the ISO 9660 file system type, as similar to Windows. So the next two parameters define the location. See, here I'm talking about this part only. So mount and then option, here you talked of the type, which type you want to mount it, whether it is VFAT, NTFS, or ISO 9660. Depends upon CD-ROM or USB stick, memory stick. Or so once that is done, the next thing to be mentioned here, it is a device. So the next parameter is device file for the media device, and the location in the virtual directory. So this is the location where you are expecting. Normally the location you can take it in either mount directory or in media directory. So here we have taken, in this part we have taken in media directory, and the name is disk. And a directory for the mount point. For example, to manually mount the USB memory stick at here, uh, this is a dev sdb. So this is where we want to mount it, but in virtual directory, so we want that location as a media and then disk. So this is all about our mount points or mount. Okay, now let's dive in deep into the Linux commands. If you have done any work in the Microsoft Windows world, no doubt you have used zip files. It became such a popular feature that Microsoft eventually incorporated it into the Windows operating system starting with XP. The zip utility allows you to easily compress large files, both text and executable, into smaller files that take up less space. So, so one of them, the gzip utility, is the most popular compression tool used in Linux. So Linux contains several file compression utilities, although uh, this may sound great. It often leads to confusion and chaos when trying to download files. So the gzip one, the gzip package is a creation of GNU GNU project in their attempt to create a free version of the original Unix compress utility. So this package includes these files. It consists of gzip for compressing files, and gzcat for displaying the contents of the compressed text files, and gunzip for uncompressing files. So these are some other utilities other than gzip. Gzip is widely used, but we have bzip to compress, and then zip. So these are other utilities. So the gzip package is the creation of the GNU. Okay, now the gzip files to be zipped. If you want to zipped, so then this is the command we have to use, gzip, and then all the files to be zipped should be mentioned. The gzip command compress the file you specify on the command line. You can also specify more than one file line, or the simply another ways, give the gzip command and then put asterisk all the files that you want to compress. So let's go to the Ubuntu machine. Just a minute, I have to drag this on the right side of the screen so that for you both commands and then exercise screen are visible. So now let's take some examples using zip and unzip processes here. So we'll take zip. So if you want a compression tool to be used, sometimes by default you will get some tools, but sometimes you have to install as you do in your Windows. Okay, Windows recently got incorporated zip also, but somehow if you do not have, you have to install. So for that we need a package manager tool or package management tool. So apt is the tool. Apt is a package manager. So let me update that apt first. Apt update. So reading could not open the log file. Okay, that's my mistake, it's my bad. Let me become a sudo first, in spite of doing a lot of changes, and then apt update, or simply you can use a sudo file sudo command at the front to do the same operation. So once update of the apt package management tool is done, then we will install the zip and unzip. These are the different tools. Okay, so let me clear the screen first. Now apt install zip and give s. So okay, apt install zip. So it will ask, do you want to continue? Yes, absolutely. Yeah. So now it's gonna install zip into my Linux, into my Ubuntu distribution. So once it is done, we will install unzip also. Once zip is done, we will install unzip too, and let's see. Okay, it's getting installed. I hope it will be finished faster, but it's taking some time. By the time you can have a look at the various utilities that we have uh, as a compression tools, and then uh, what are the ways of commands that we can use. Okay, it's done. So now let's install uh, unzip also, apt unzip. Again, I'll give vibe before only. Okay, zip and unzip both got installed. Now let's go to the cd, let's go to the var, so log, so there we can find some logs. Okay, here we have some files in it, dpkg, a lot of files. Now what we will do is we want to zip these files with the with a name. So how can I do that? I can use zip command, and then R, I want to zip it all the directories recursively. So, and the name I want to give is Jenkins, and then date 10/01/2023, and then zip, and all the files in this directory, 93%, and still it's going on because there is a huge amount of files are there. So I think let's check. It's done. Jenkins, and date, and year, and file. This is your zip file. Your compression is done. This is how we do the compression here. So if you want to check, you can check ls ltr, and then uh, Jenkins, right? So Jenkins asterisk. So we have only one, that is this. See, it's clearly not a directory, it's a file, it's a zip file, and it was created at this time, at this second, at this moment. Okay, so now let's jump into the cd opt. Then let's check what all files are there. I think it's completely empty. So what I will do is we'll copy that, we'll move that file into, just a minute, it's in var log. So let's move this zip file jenkins dot this jenkins dot zip file to opt. Then we'll move to the opt. I think we should have, yeah, we have the jenkins file. Yes, a zip file we have. So now I want to unzip it. I want to unzip it. This is archive. I just want to unzip it using tool. So for that I need unzip. We have installed unzip also. So unzip Jenkins, and we have only one file, and enter. Let's see. That's it. Oh, I'm in a wrong. Yeah. I got completely unzipped this. Yes, this is your initial file, zipped file, and then once it is unzipped, these are the files. The red one is zipped one, and a zipped file. Rest all were unzipped. After unzipping the zipped file, the remaining files we got it. So this is how a zipping and unzipping can be done in Ubuntu, or it may be in CentOS also. So now let's go for the archiving data. This is very much important for a system administrator or a deployer who works on deployment. Of course, I do. So it's very important. I would like you to I would urge you to focus on this very much. So although the zip command works great for compressing and archiving data into a single file, it's not the standard utility used in the Unix and Linux worlds. By far, the most popular archiving tool used in the Unix and Linux is the tar command. The tar command. So, the tar command, it will have a function parameter. The first one is tar, then the function parameter defines what the tar command should do. As shown in the following table, the tar command functions as, so each function uses options to define a specific behavior for the tar archive file. So the basically this table lists the common options that you can use with the tar command. So these options are usually combined to create, I will demonstrate that also. So these options are combined to create the following scenarios. First, you want to create an archive file using this command. So if you see this, the first one, C, the C function or C option, long name is create. So it creates a new tar archive file. X extracts file from an existing archive. T lists the contents of an existing tar archive file. Now using all these and you have some functions, and in addition to that you have few more options. That is, C changes to the specified directory. F outputs results to the device file, and V lists files as they are processed. P preserves all file permissions. Now these options are, now what are options that we have seen so far? C, X, T, V, P, F, all these options are usually combined to create the following scenarios. First, you want to create an archive file using this command. Then the first command is star and -cvf. This is most famous one and widely used in industry. So CVF, this command creates an archive file called test.tr containing the contents of both the test directory and the test2 directory. Then the second one, it lists but does not extract the contents of the tar file test tar and tar.tf, but whereas tar xvf, this command extracts the contents of the tar file test.tar. If the tar file was created from a directory structure, the entire directory structure is recreated starting at the current directory. So now let's try it out in Ubuntu. Let's clear the screen first. Yes, we have cleared it off. Now we'll move it to the leftmost portion of our screen. So now let's again jump into the cd and then var log. So what all files are there? So you can clearly see Amazon apt or .log. I'll put in long list. So there are files and there are directories. The blue ones are our directories, rest all are files. Okay, ls. Okay, the blue ones are our directories, and then the white ones are our files. Let me clear the screen again, and then so let's check the pwd where we are, and the tar. Let's check for tar help. This is your tar. So tar, so valid arguments and complete information about the tar, and here if you see the information about the tar and how can you use it, you will have a detailed information about the tar, but that's fine. We are not worried about the help now, so we will take up some challenge now. Okay, so now let's go to the let's go to the cd var log. Of course we are there. Let's check it. Let's cross check it. Yes, we are in var log. So and here we'll check what all files are there. lsl. Okay, a lot of files are there, or ls. So now we have to archive, we have to compress all these files into uh, uh, all these files into tar.gz. Okay, so for that, tar, and then what all options we have to use? You have to use c here, c, and you have to use v, list files as they are processed, cv, and um, z. We have to use z, and finally f. c, z, v, f, and name we will give Jenkins, and 10/01/2023 dot tar.gz. This is our archive, and all files which are there in this. So let me add dot. Tar file changed as we read it. So now let's check. That's it. Here it is. Jenkins tar.gz. This is what your file. So now what we will do is we'll move this file to some other location. So move Jenkins dot tar.gz to tmp. So let's move to tmp. Yes, it is in tmp. We can clearly see that ls, the first one, Jenkins dot tar dot gz. So now I just want to archive it. I just want to extract all the information, untar it. In Linux world we call this untar it. Tar is done, now untar it. To untar it, I have to use the following options. Tar and begins with x, extract, and then same zvf. These are common. C and x is the one changes, and rest remains same. So and then Jenkins tar.gz, and press enter. That's it. Completely your temp directory has messed up with lot of folders and files. Now a lot of directories and files, you can clearly see that, because the tar, that tar.gz, the tar file has been untarred. The tar file has been untarred, so that's the reason. So this is how uh, we use a tar to archive the files, to make an artifact and untar it or extract the files which are in artifact. Okay, package or unpackage an amount of folders or files or directories. So so this is another way of getting complete help from man. So GNU tar manual, tar an archiving utility, tar an archiving utility. So this is how the syntax of the tar command works. So tar, and then you can put plenty of options together, you can run plenty of options together, and then you have to go for the arguments. Okay, then there are different options, you can explore each option, and description about each option. See the famously used option CFV, or CZVF, or XZVF, and all those things you can get it from the help or manual. So kindly go through it, and get the more clarity about tar before you start working on it, because this is a very very useful tool of Linux. So exploring the shell types, the shell program that the system starts depends on your user ID configuration. For example, in the etc passwd file, the user ID has its default shell program listed in the field number 7 for its record. So the default shell program, it started whenever the user logs into a virtual console terminal or starts a terminal emulator in the GUI that we have discussed in our previous sessions. So let me take up this is CentOS, so I'll take uh, Ubuntu here. So after that we can change over. That's okay. So let me clear the screen first. Yeah. So now I'll cat etc, but before that I'll become a root user. It's not a big deal. Then cat etc and pass wd file. So if you look into this file, I'll just there is something wrong. Okay, clear. Yes, here it is. If you look into this, Ubuntu is our user. Here it is, you see here, Ubuntu is our user, and exactly here, this is the part which I'm talking about. This is the default shell of that user. When you invoke a shell, and this shell is going to be started, this shell is going to be started. That's what I'm talking about. Now, and this above in the above example, so where I have mentioned here, the Surya Charan is the user, and cat etc, okay, cat etc passwd. So in this uh, here it is. Here Surya Charan Teja is the user, and bin bash is default shell. That's what I want to say. And similarly, the bash shell program resides uh, in the bin directory. The bash shell, whatever we are using, that resides in the bin directory. So a long listing reveals a bin bash is an executable program. So what we can do is simply, so let's go to the Ubuntu, clear the screen, and ls lf, and then bin bash. That's it. Here it is. It's a file, it's not a directory, and this is what. So here you have that bin bash uh, files. Okay, that's applicable for all others. Now several other shell programs are on this particular, for example, CentOS distribution. they include tch, which is based off the original C shell. So okay, let's try to put up both. And okay, this is our CentOS. This is our I hope it's alive. Yes, it's alive. Now what we'll do is cat etc passwd. So here this is also using bash, but I hope we should have cd bash, sorry, bin, and a pipeline, and a grep, and then tcsh, sorry, tch, and tcsh. No, just I want to show, but Jed new. I just want to find out. Clear. So that's how few CentOS distributions can use tcsh also. So and let's try to do this and see. This is ls. Okay. Okay. ls lf bin tcsh. No such directory, so this is not using tcsh. So some use, not all. Let's look for dash at least for dash ls lf /bin dash, no dash 2. It's these are different shells, but some will have, some may not. We cannot expect in all, but still let's try and check. And bin and csh, if it is not here. Okay, so it's not there, so let's look into let's try to. So basically, mm, the default interactive shell starts whenever a user logs into a virtual console terminal or starts a terminal emulator in the GUI. That's a graphical user interface. However, another default shell such as bin sh is the shell you can run it directly by typing the command bin dash. So you are not forced to stick with your default interactive shell. You can start any shell available on your distribution simply by typing its file name. For example, to start the dash shell, you can run it directly by typing the command. So if it doesn't have, you can actually download it and you put it into the binary directory and you can use it. It doesn't look like anything happened, but the dash shell program started, and the prompt is a CLI prompt for the dash shell. You can leave the dash shell program by typing the command after the exit. So that's how the whole system works. But here, so I think let's look into this Ubuntu, and let's try to see what's gonna happen. Okay, let's clear the screen first. I don't think. Okay, it's cleared. So let's ls. Okay. So now I'll try to look for other maybe in dash bin dash. Yes, here it is. It has a dash, so we can use this. Let's use it directly. I will type bin and then dash. So that's it. You are using another shell. Normally we use bash shell, but now we are using dash shell. Da dash shell. D for dog, dash shell. So that's how we use it. Now you can do all operations ps. Okay, it's dash. Here it is, it's dash. And after the ps, if you want to do listing here, you can list it. And you can clear the screen. You can do whatever you want, because it is another type of shell. You can do, it will have its own rules. Most of the rules will be similar, but few rules will change. That for scripting, not for the uh, normal way of giving commands. Okay, so if you want to come out of this shell, you just type exit. That's it, and clear the screen. So that's how it works. uh, then let's sneak peek into the parent child relationship. Let's explore the parent and child shell relationships. The default interactive shell started when a user logs into a virtual console terminal or starts a terminal emulator in the graphical user interface is a parent shell. As you have read so far, and as you have listened so far in this course, or you might have read in some blogs, so a parent shell process provides a CLI prompt and waits for the commands to be entered. That's what happens. Now, when the bin bash command or the equivalent bash command is entered at the CLI prompt, a new shell program is created. So this is a child shell. So now a child shell also has a CLI prompt and waits for the commands to be entered. So the whole thing works as the following way. So when you log into a virtual console terminal, your parent shell automatically opens. When you issue a command bash in the parent shell, then it creates a sub shell or child sub shell. Then here is your child sub shell. If you issue a command bash again in this child sub shell, then it will create one more sub child or sub shell, or it's called grandchild sub shell. If you issue a bash again it creates a sub shell. This is a great grandchild sub shell. So there you can give ps some forest and this kind of commands, basically to see the overall map or overall trajectory or overall tree diagram of the shells that you have created so far. So let's get into the one of, I think this is Ubuntu. Okay, so let's keep this Ubuntu here and clear the screen first, and let me extend it a bit more here. Okay, fine. So for psf, this option shows the processes presently running from the parent shell. And if you just these all options we have seen. Now ps double hyphen forest, this is a long option. When you give this, you'll get this kind of tree diagram. So you'll clearly get it. Sudo, and after the sudo, the bash first cell is created and ps has been given in this cell. So that's how a parent child relation can be clearly can be seen. But here what I want to demonstrate, is a parent-child relationship in a graphical way. So for that, let's begin with, let's clear the screen. Okay, so now let's first give uptime. Okay, this is the information. This is uptime is one command. So we have two users in it, and load averages and all that information, blah blah blah. That's not important for now. So then I'll give ps. So these are the three utilities which are there, which are presently exist. And then I will give you ls, then ps forest e. So in this case, you got all, all processes which were running and which are running. So few processes which were dead were also shown using this command. Okay. So now what will we do is we will go for the demonstration of parent-child subshell. So here first let's enter the bash command. Bash, this is your first thing. So after entering the bash here, a child shell is created. To check that, let's give psf. That's it. Here it is, one more bash. There is a first bash, it's a parent bash, and then second bash, and inside that we have given a psf command. So now the second psf, which is executed from within the child shell. From this display you can see that two bash shell programs are running. The first bash shell program is the parent shell process and has the original process ID, the PID, that is 13048. And then the second bash shell program on the child shell process has a PID of 13112. So note that the child shell has a parent process, a PPID of 13048. So denoting that the parent shell process is its parent. So now let's give ps forest. Here it is. This is your parent bash, and then this is your child bash. Inside the child bash we gave this. So I'll give uptime here. Again, let's check it. Yes, we are still in this thing. So now what I'll do is I'll create a one more grand child subshell. So for that, again I'll give bash. So now let us give a ps forest to see where are we. Here it is. This is a parent shell. This is a child subshell. This is a grand child subshell, and that's where I'm operating. And we'll create a one more bash. Okay, of course we are in grandchild bash, so we have only one. So I'll create bash one more time. So this time if I go up and go down, no command set, because I am completely in the new shell. There's a great grand child subshell, so I will give ps forest to see. Yes, that's it. Parent, child, grandchild, great grandchild. So this is how now I can do any commands. I can give any commands inside that, and then presently I'm operating in great grandchild subshell. So now if I want to come out of this, there is only one option. Just give exit, and then ps forest. See, one is done, one is gone. So now I'm in grandchild subshell, not a great grandchild that was dead, that was exited. So I'll clear it and then I will exit it again, and then so ps forest, here it is. Now it's a child one. I am in the child one. Now I'll exit again and then ps forest one. Okay, ps forest, that's it. So now I'm the parent. Now I'm the parent shell. So this is how the relation between the parent shell and child subshell works. So now let's look at the process lists. On a single line you can designate a list of commands to be run one after another. Obviously we can do that. So this is done by entering a command list using a semicolon between commands. So in the preceding example, the commands all executed one after another with no problems. However, this is not a process list. For example, for a command list to be considered a process list, the commands must be encased in parentheses. So that's what we do here. So though the parenthesis addition may not appear to be a big difference, but they do cause a very different effect. Adding parenthesis and turning the command list into a process list created a subshell to execute the commands. So what we will do is we will take up again Ubuntu, I think, and move it to the right side of your screen now. And then let's clear the screen. We are in parent bash. So let's execute the commands together. pwd colon ls colon cd colon and pwd again colon and ls. That's it. That's it. Lot of activities had taken place. So the better way to do the same operation, which we have done on top, is to do it using, let me clear the screen, do it using the parenthesis. So I'll do with the parenthesis now. Open parenthesis pwd, then ls, then uptime. Let's see how it's gonna work. That's it. It has given complete information about that. It has executed one by one, and finally the last command for us is, after listing the next command for us is uptime. So here it is. Here is your uptime. It's been up for 59 minutes and two users are using. One is Ubuntu, other one is a root user, and load average is 0.02 and other parameters are 0.08 and 0.04. So next, creatively using subshells. So what is creativity that you can put into the subshells? So one productive subshell method in the interactive shell uses background mode. That's what the creativity I'm talking about. So before discussing how to use a background mode and subshells together, you need to understand background mode itself. So investigating the background mode. So running a command in the background mode allows the command to be processed and frees up your CLI for other use. A classic command to demonstrate a background mode is the sleep command. Sleep command. So what happens with the sleep command? Oh, it sleeps. Yes, it sleeps. Let me clear the screen first. Sleep 10. Yeah. It's gone. You cannot access it. It's gone. Wait for 10 seconds. So after 10 seconds, so that bash has slept for 10 seconds, and then no, that's a huge stuff is there. I can't phone. That's okay. No, I have to search for that to show that what happened, what had happened. Okay, so that's how a sleep command helps us. So now um, the sleep command accepts as a parameter, as an option, uh, as an argument, the number of seconds. That's what the sleep command accepts as an argument, the number of seconds you want the process to wait or sleep. So this command is often used to introduce pauses in shell scripts. So the command sleep 10 causes the session to pause for 10 seconds and then returns a shell CLI prompt. So the sleep command was told to sleep for 3000 seconds. That means it's approximately equivalent to 50 minutes. Fantastic. In the background, when you put "and" in the background, so when it was put into the background, two informational items were displayed before the shell CLI prompt was written. The first informational item is the background jobs number one displayed in the brackets, and the second item in the background jobs process ID is this. So in addition to the ps command that you can use, just a minute, so here it is. So sleep 3000, and it's gone to the background. So this is what I'm talking about. I just want to demonstrate here. So when you done it, when you do it, when you do this, what had happened, it had displayed two informational items on the screen. The first one is the number, that's the background jobs number, that is 1, that was displayed in the brackets, and the second item is in the background jobs process ID, that's a 2396. Now in addition to what we have done uh, uh, using this, we can use ps command also. So you can use the jobs command to display background jobs information. So the jobs command displays any user's processes currently running in the background mode. So let's do it. Yeah, yep, yep. So psf. So here you can see these are the one which are running, and one more here you can see that sleep also. Now you can use one more command, that's jobs command. Yes, here it is. Here the jobs command is specifically used for that. It's 1 plus and then it's running. What is the work? It's a sleep. How many seconds? 3000 seconds. That too where? In background. That's how our jobs command will be helpful in finding these jobs which are running in background. In background. So let's do one more exercise before moving to the another topic. So let's sleep for 10, sorry, just 5 seconds, so that we can quickly recover back. Yeah, yes, it's sleeping. Yeah, it got up, it got up. So let's do the psf. There is one sleep. The background job still it's running. So let's give jobs L for the long listing. Yes, it's 10006 running. That's 3000 seconds it's been running. You can create one more just for 15 seconds and then end. So this job ID is 2 and PID is 19914. So let's do the PSF. Yes, one more, both were added. It will only sleep for 15 seconds and then it will get up. We'll check the jobs. Yes, you have two now. One is done. For this, I just want to demonstrate this. I just put 15 seconds. So once it is done, the job is no more active. So no more work is happening in background. So that is closed, and it will take 3000 seconds to be seconds to shut it. This background image. So other one is done. This one is still running. This is how we use jobs and psf command to view the jobs which are running in background, and the sleep command with and character, with the help of this sleep command and end character, this is how we run background jobs. So now, uh, putting process lists into the background. As stated earlier, a process list is a command or series of commands executed within a subshell. So using a process list including sleep commands and displaying the bash subshell variable operates as you would expect. So a 4-second pause occurs. For example, the if you take this example, a sleep 4 and then echo Hare Krishna and sleep 4. So what happens with this? A 4-second pause occurs. Hare Krishna is displayed, indicating a single subshell level. That's a child subshell. And then another 4-second pause occurs before the prompt returns back. So nothing too dramatic here. So let's check it and enjoy the pauses. Okay, let me clear the screen first. Let me open the parenthesis. First sleep and then echo what I want to echo. One and only Hare Krishna. Then colon, again sleep for 4 more seconds and then close the parenthesis. Okay, sleep for. Okay, that's my bad. Okay. Done. Waited for 4 seconds and is still waiting for 4 more seconds and then finally came up. So let's clear it off, and then this time we will put 10 second or 6 seconds to clearly distinguish. Sleep 6 seconds and then echo Hare Krishna and then colon and then sleep for 6 more seconds. No, don't sleep for 6 more seconds. Sleep for 10 seconds and let's close it up. So sleeping 1, 2, 3, 4, 5, 6 is done. Hare Krishna is echoed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. That's it. This is how helpful it is. Basically, you can automate your things. You can execute certain commands at the certain time. So this is very helpful. So that's the reason I have covered this concept too. So now, uh, if you want to run the same thing in the background, you have to use and, nothing else. So putting the same process list into background mode can cause a slightly different effect with the command output. So putting the process list into the background causes a job number and process ID to appear and prompt returns. However, the odd event is that displayed number 1 indicating a single level subshell is displayed by the prompt. Don't let this confuse you. Simply press the enter key and you get another prompt back. That's it. Okay, so let's try this with the we'll run the same job in background. Okay, for that nothing much, put end. That's it. This is your job ID. and this is your, that's it, it got printed, though it's running behind. So without you letting know, without you to stop it, it will, while you are working, while you're doing something else, it will finish the activity and it will come up, and click enter. The job is done. You're on your foot. This is how it works. This is how much helpful it is. So next, what let's understand some of the shell built-in commands. So while learning about the GNU bash shell, you likely have heard the term built-in command. It is important to understand both the shell built-in and non-built-in external commands. So built-in commands and non-built-in commands operate very differently. Let's look at the external commands first. An external command, sometimes called a file system command, is a program that exists outside of the bash shell. They are not built into the shell program. An external command program is typically located in bin or user bin or sbin or user sbin. So these are the location where these external commands will be stored. Example, the ps command. The ps command is an external command. You can find its file name by using both the which and the type commands. So whenever an external command is executed, a child process is created. This action is termed forking. Conveniently, the external command ps displays its current parent as well as its forked child process. So this is how it works. Okay, so let's go to the Ubuntu again, but this time it's on right. Yeah, let me clear the screen. Yep. So which PS? Because this is an external command. Yes, what I told you. This is in user bin PS. This is absolutely an external command. Then type A and then PS. So PS, oh, okay, you have bin PS as well as user bin PS, two PSs. That's what I'm talking about. So this is all about the external commands. It's very helpful and it's very useful to understand the difference between an external command versus a built-in command. So now looking at built-in commands. So built-in commands are different in that they do not need a child process to execute. So they were compiled into the shell and thus are part of the shell's toolkit. No external program file exists to run them. Both the cd and exit commands are built into the bash shell. You can tell a command is built in by using the type command. So let's do it. Okay, I'm sorry. Let's do it. Ubuntu, where are you? Now I will shift you towards left. Okay, let's do it. Type cd. What is this? This is a shell built-in. That's it. Now, so be aware that, and type exit also. Let's check that too. Type exit. Yes, it is. Exit is a shell built-in. Now, because they do not fork a child process to execute or open a program file, built-in commands are faster and more efficient. So let's do few more exercises. So let's check type and then what is echo? Echo is a shell built-in, and echo is also there in that. And which echo? Echo which are used is user bin echo. Basically, to see multiple flavors for commands, use the A option on the type command and give to find out which to find out the directory of that command, from the which directory the command has been executed. You use which. Then we'll do it for the type apwd also. Let's do it one by one. So type apwd, let's get it. It's a shell built-in, and this is where the location of the file. And which pwd that we are using? It's from user bin pwd. So then history A, we'll check. Let me check it, just a minute. History A, nothing much. Okay, that's all. So be aware that some commands have multiple flavors. As you have seen, I'll put the screen on left side so that it would be visible. Yeah, here it is. So some have a multiple flavors. User bin example this. Uh, User bin pwd. So I have a built multiple built-in command flavor as well as an external command flavor, both. So these flavors are slightly different. To see multiple flavors for commands, use an A option on the type command that we have done it. So using this type A command shows both types for each of the two commands. Note that which command shows only the external command file. Now, so let's close it. This slide. After looking into this, now what we'll do is how can using the history command, basically. So a useful built-in command is the history command. The bash shell keeps the track of commands you have used. So you can how it will do using the history command. You can recall these commands and even reuse them. To see a recently used commands list, just type history command with no option. Let us do it. History. Here it is. Everything, almost 63 commands we have used in this bash, and all are safely stored by your history. So let us do history option A, nothing much. Then ls A. So let's clear it of everything and cat dot where it is bash and then history. So no such file here, it would be somewhere else. You don't need to find, but that's where through that it's going to save your all the recent commands that you have used so far. Now let's look into Linux environment variables. So Linux environment variables help define your Linux shell experience. Many programs and scripts use environment variables to obtain system information and store temporary data and configuration informations. Environment variables are set in a lot of places on the Linux system, and you should know where these places are. So this slide walks you through the world of Linux environment variables, showing where they are and how to use them and even how to create your own. So let's begin with exploring environment variable. So the bash shell uses a feature called environment variables to store information about about the shell session and the working environment. So this feature also allows you to store data in memory that can be easily accessed by any program or script running from the shell. It's a handy way to store needed persistent data. Now there are two environment variable types in the bash shell. One is global variables and second one is local variables. So now initially let's look at the global environment variable first. So global environment variables are visible from the shell session and from any spawned child subshells. Local variables are available only in the shell that creates them. So this makes global environment variables useful in applications that create child subshells which require a parent shell information. So the Linux system sets several global environment variables when you start your bash session. For more details, uh, for example, the system environment variables almost always use all capital letters to differentiate them from normal user environment variables. That's how you differentiate a environment variable, a global environment variable, to a user variable. So to view a global environment variables, use the env or the printenv command. Okay, just a minute. Yep. Let's get into the put it on right side. Clear the screen. Print env. Here it is. Here it is. There are a huge number of environment variables. User Ubuntu. User Ubuntu. And let's give echo. Sorry. Echo dollar user. What is that? Ubuntu. Then print. Let me clear the screen first. Print env home. It's home Ubuntu. Or another way of printing the same is through home. Then ls dollar home. Nothing. So, and we'll check print env. There are a lot of term, user Ubuntu, and path. Let's take the path. Path as a variable. So echo path. Let me clear this first. So echo path. Here it is. This is how environment variables helpful. So what I will do is I'll create a child subshell, and then I will give you echo path. Here it is. Here it is. That's why we call it as a we call them as a global environment variables. Global environment variables. So you can also use the echo command to display variables value. That we have done it apparently. So using the dollar sign along with the variable name does more than just display its current definition when used with the echo command. So the dollar sign before a variable name allows the variable to be passed as a command parameter. So that's all about global environment variables. So now let us look into the local environment variables. Local environment variables, as their name implies, can be seen only in the local process in which they are defined. So even though they are local, they are just as important as global environment variable. In fact, the Linux system also defines standard local environment variables for you by default. However, you can also define your own local variables. So these, as you would assume, are called user defined local variables. What is that? User defined local variables. So here we have the set command. What the set command does is, the set command displays all the defined variables, all variables which are defined for a specific process. That's what the set command does. So including both local and global environment variables and their user defined variables. Okay. So set, you see that a complete information about the set command that we got it here. So here all global environment variables are displayed using the env or printenv commands appear in the set commands output. You just want to check it one more time. I shown it. I shown it. So here it is. Here you can clearly see, and in the path, everything. So the additional environment variable are the local environment and user defined variables that also can be seen here. So now the subtle differences between the commands env, printenv and set is, the set command displays both global and local environment variables and user defined variables also. It also sorts the display alphabetically. The next thing is the env and printenv are different from set in that they do not sort the variables, nor do they include local environment or local user defined variables. So used in this context, env and printenv produce duplicate listings. However, the env command has additional functionality that printenv does not have, making it the slightly more powerful command for us. So now let's look into setting user defined variables. So you can set your own variables directly from the bash shell. This section or this slide shows you how to create your own variables and this slide shows you how to create your own variables and reference them from an interactive shell or shell script program. After you start a bash shell or a span shell script, you are allowed to create a local user defined variables that are visible within your shell process. You can assign either a numeric or a string value to an environment variable by assigning the variable to a value using the equal sign. So if you need to assign a string value that contains spaces, you need to use a single or double quotation mark to delineate the beginning and the end of the string. So Without the quotation marks, the bash shell assumes that the next word is another command to process. So notice that for local variable you defined. So you use the lowercase letters, while the system environment variables you have seen so far have all used uppercase letters. So what will we do? We'll jump directly into our Ubuntu and let's use it. Let's clear the screen. Okay, first echo my variable, nothing. My variable does have nothing. It does have nothing. So that's the reason first we will define the my variable. My variable equals to Hare Krishna. That's it. Now let's echo it. Here it is. This is how you set a user defined variables. That was simple. Now anytime you need to reference the my variable, user defined variables value, just reference it by name. That's my variable. That's it. Um, if you want the big one, so you have to use a double quotation. Similarly, we'll create where sorry var1 and quotation Hare Krishna. Yes, echo var1. That's it. Oh, sorry, that's my bad. Sorry. Yes, here it is. Okay, this is how it works. The setting up a user defined variables. So now if you need to assign a string, okay, that so now these are the two examples we have covered up in our uh, exercises also. So now let's move on to the setting up a global environment variable, global user defined variable. So after you start a bash shell, you are allowed to create a local user defined variables that are visible within your shell process. So you can either use a numeric or same thing, the procedure remains same. So now how to do this? After defining and exporting the local variable, that's my variable, that's a local variable, a child shell was started by the bash command. So the child shell was able to properly display the my variable's value. So the variable kept its value because the export command made it a global environment variable. That's what happened here. So my variable consists of a value I am a global now. Export, then we'll use export it, and after exportation if you call echo my variable, it should able to show it because it has become a global now. That's echo. So now this can be printed even in the child bash shell also. That's how you can set a global user defined variables too. So here it is, and this time keep it here. So again I'll take the same my variable, I'll define it one more time, and then I'll change this to sorry it's I am global now. Yeah, my variable is ready. Now I just want to I'll export this my variable. Yes, it got exported, and then let me do echo. echo I'm global now. That's it. Let's go to the another bash, another shell or child bash, and there also you should able to see var1 is a variable which is created in a user defined variable which is created in parent shell. So now I am in child. Yes, here it is. I am a child shell. Now if I call echo of var1, nothing happened because it does not exist in the child, because it's not global, it is local. It's a local. So now, whereas I've set it, I have export the my variable one, I made it as a global. It should visible here. Here it is. Here it is. So that's how you can convert a local variable into a global variable, a global user defined variable. So now how to remove? The next question is how to remove that. How to remove an environment variable. Of course, if you can create a new environment variable, it makes sense that you can also remove an existing environment variable. So you can do this with the unset command. You can see that a set and unset command. Now when referencing the environment variable in the unset command, remember not to use the dollar sign. That's how it works. Let's do it. Here it is. Set and then my variable. Okay, now let's do it. Echo. It still exists. Unset. So using this, that's it. Using this command unset, you can basically remove from the environment variable, from the global, and you can make it as a local. That's how you do it. Just unset and then variable name. Of course it's gone. That's it. Okay, so now let's learn about variable arrays. So a really cool feature of environment variables is that they can be used as arrays. An array is a variable that can hold multiple values. So values can be referenced either individually or as a whole for the entire array. So to set the multiple values for the environment variable, just list them in parentheses with values separated by spaces. This is one way. Let's do it. Let me clear the screen first. Yeah. First one is my test and open parenthesis 1, 2, 3, 4, 5. That's it. So echo my test 1, 1. That's it. 1. The array. And again I'll do 1. Again I'll do 1. So it will only print the first or one element of that array. That's how it works. So not much excitement there. If you try to display the array as a normal environment variable, you will be disappointed. Of course, that's how arrays work here. So now to reference an individual array element, you must use a numerical index value which represents its place in the array. So the numeric value is enclosed in square brackets. It's like indexing in Python. Okay, let's do it. let's get back. Yep. So echo same. Okay, we'll use a security. We'll use the security. That's a square. That's a curly braces. My test, and then indexing. I want the second element, and then close it. Here it is. The second element 0 is the index. The 0 index is 1. Uh, index 1 is 2. Index 3 is Index 1 is 2, index 2 is 3, index 4 is uh, 5. Okay, so that's how you can see other elements of that array. So now to display an entire array variable, you use the asterisk wildcard character as the index value. Let's do it and see what's going to happen. Ubuntu again, echo dollar braces, and then my test, then indexing asterisk, and close it, and then close it again. Here it is, the complete array has been displayed or printed. That's how it works. And finally, you can remove the entire array just by using the array name in the unset command. It's simple. It's demolishing is easier than constructing. Oh, nice. Okay, let's unset it. Unset my test. That's it. It's gone. All gone. All gone. Everything is gone. That's what I say. Demolishing is easier. Be a destroyer than a constructor. Just kidding. I don't take it seriously. Okay. With this, we are done with Linux environment variable. I hope you got it. Now let's look into Linux security and user groups. No system is complete without some form of security. There must be a mechanism available to protect files from unauthorized viewing or modification. So the Linux system follows the Unix method of file permissions, allowing individual users and groups access to files based on a set of security settings for each file and directory. So this section discusses how to use the Linux file security system to protect data when necessary and share data when desired. Let's begin with Linux security. The core of the Linux security system is the user account. Each individual who accesses a Linux system should have a unique user account assigned. The user's permissions to objects on the system depend on the user account they log in with. The Linux system uses special files to match the login name to a corresponding UID value. So this file is the etc passwd file. The etc passwd file contains several pieces of information about the user. So here is what a typical etc passwd files look like on a Linux system. Let me clear the screen first and I'll show you how it looks like. So that's cat, wait, sudo I, clear it again, cat etc and passwd pipeline. And let's take one example. That's the reason. It's a grep channel. Okay, let's. Yes, here it is, the big one. So let me extend this bit. Yeah. Okay. Now, if you see this, here it is, the Ubuntu user. Now, the fields of the etc passwd file contains the following information. The first one is the login username, then the password for the user, then we have, okay, let's then we have the numerical UID of the user account, that's user ID, and then the numerical group ID, that is GID of the user accounts, that is this, and a text description of the user account called as the comment field, this is the comment field, then the location of the home directory for the user, this is that, the location of the home directory for the user, and the final one, the default shell for the user. This is what uh, uh, this is the data that will be revealed and carried by the passwd file. Now similarly we have the etc shadow file. The shadow file provides more control over how the Linux system manages the passwords. So only the root users has access to the etc shadow file, so making it more secure than the etc passwd file. So let's get back to our Ubuntu one more time and clear the screen, and cat etc shadow file, here it is. So there are, let's take any example. Okay, the Ubuntu, here it is, the Ubuntu one. Let me zoom in more. Okay, yeah, Ubuntu, take this example. So there are 9 fields in each etc shadow file records. The first field is the login name. This is a login name corresponding to the login name in the etc passwd file. Okay, let's put it both, and then other one is here, and this one will come on left of it. Okay, here we'll have CentOS, and yes, I'll clear the screen here. I'll clear the screen here too. Now CentOS, what will we do here is we'll cat etc passwd, and here cat etc shadow. Yes, so let's see example. This is CentOS is the username, and here Ubuntu is the username. That's how the login name that is similar to the passwd file. Then you will have an encrypted password here it's not there, of course, but normally you should have an encrypted password. For this Ubuntu there is no encrypted password. Then I'll show it in a different one. So here it is. So here I will open it. Let me clear the top one, and then cat etc, oh sorry, shadow. Yep, here it is. So this is the username. Then from here till here, it's our encrypted password. That's our encrypted password. So here there is no password. Okay, then the number of days after that, the number of days since January 1, 1970 that the password was last changed. There is no password, only to change here. Okay, it's 19224 because I have never changed the password, so it's too big. Then the minimum number of days after that, 0. The minimum number of days before the password can be changed, the minimum number is 0. Then after that, the number of days before password expiration that the user is warned to change the password. And then the next one is the number of days after a password expires before the account will be disabled. That's the 7. And the next one after that, these are 3 empty, 2 more, 1 and 2 more are there. That's this part, the date since the user account was disabled. And then the final one is a field reserved for future use. It's not specifically used for some other purposes, but it's for future use. If you want to add, you can add it. So using a shadow file that you are viewing now, viewing a shadow password system, the Linux system has much finer control over user passwords. It can control how often a user must change his or her password. Everything can be given here and can be operated. So when to disable the account if the password hasn't been changed. So this is how. Now you know about users and groups. So the fundamental reason behind creating users and attaching them to the groups is to create a certain kind of restrictions and permissions and conditions in accessing the resources of that system. So that's where the permissions comes into the picture. So it's time to decode the cryptic file permissions you have seen when using the ls command. This section describes, the slide basically talks about how to decipher the permissions and where they come from. So this is how it looks that you have seen before. For that, what I will do is I will take up the Linux. Yeah, this one. Okay. So now the clear the screen first, and then ls lrt. We will take. Yeah. Anyway, we have very few files. So now after doing ls lrt in this, we have 3 files in it. So if you look into this long listing file, the first field in the output listing is a code that describes the permissions for the files and directories. The first character, this is the first character. Is it clearly visible for you? This is the first character on the leftmost. The first character in the field defines the type of the object. Basically, for just a dash for files, and D for directories, L for links, C for character devices, and B for block devices, N for network devices. Then after that, you see three, you see the three characters. Each set of three characters defines an access permission triplet. So this is the first triplet, this is the second triplet, this is our first triplet, this is our second triplet, and this is our third triplet. These three triplets basically defines an access permission for three different types of users. So the first one, the first one, we have R, W, and X. In this, the R is for read permission for the object, and W is for write permission for the object, and X for execute permission for the object. So if a permission is denied, if a permission is denied, a dash appears in the location. A dash appears in the location. That's what here you can clearly see. So a dash dash dash, that means here execution permission is denied. A write execution, both permissions are denied. So the three sets relate the three levels of security for the object. So the first triplet, the first triplet the first triplet related to the owner of the object. Then the second triplet, group that owns the object. And the third triplet, everyone else on the system. These are the three triplets permission system of Linux. So this, the first triplet anyway, the first dash, it defines the type of the object, and then this is the first triplet that talks about the permissions for the file owner. So here it's RWX, that means owner has read, write, execution permission for that file. And the second triplet is permissions for the group members, where this owner is associated. So it also has a read, write, and execution permission. And the third triplet is permissions for everyone else other than owner, and then group members which are associated with the owner. Other than these people, everyone else will have these permissions. Of course, RWX, these also have a read, write, execution permission. So other than that, the remaining components of this has been explained before itself. So Linux file permission codes goes like below. First one is dash. Dash means no permission. So binary it's a 000, in octal it's 0. So we'll look into the octal ones. Whereas double dash X, for example, this is basically a triplet, execute only permission. When it is a double dash X, no read, no write, execute only permission. If it is dash W dash, means write only permission, and dash WX, write and execute permission. R double dash means read only permission. R dash X read and execute permission. RW dash read and write permission. RWX all permissions are given. Read, write and execute. Basically this is in binary form. When these are, of course we are doing it using these alphabets and dash. However, the system understands this in a binary form. This is what happens. So next we will look into the change in the permission. Now we have seen how the permission works, but now we have to do some modifications in the permission. You want to give access to your group members or the other members which are neither in your group. So how will you do that? If you have already created a file or a directory and need to change the security settings on it, Linux has a few different utilities available for this. This section or this slide shows you how to change the existing permissions, the default owner and the default group settings for a file or a directory. So let's begin with the chmod. Chmod, change mode. Chmod command allows you to change the security settings for files and directories. The format for the chmod command is clearly visible on your screen. So chmod, this is the main command. After that you can have options, and after that mode, which mode you want to have, and then file. This is your argument. So the mode parameter this mode parameter allows you to set the security settings using either octal or symbolic mode. We have to decide whether you want to go with the octal mode or symbolic mode. The octal mode settings are pretty straightforward. Just use the standard 3-digit octal code. Octal code you want the file to have. So example, this is a 760. That's a file1.txt 760 example. Okay, but before that, let's go get back to the previous slide and see octal codes. For only execution, the octal code is 1, and for only writing, the octal code is 2, and for only reading, the octal code is 4. So 1, 2, 4. 0 no for permission, 1 execution, 2 writing, 4 read. This is what the octal code. I want you to remind you one more time. So when you say 7, you give read, write, execute all permission. When you say 6, read, write permission. When you say 5, read and execute permission. So these are the things we are going to use now. Okay, so now let's do a small let's use, I think it's got clear. Okay, let me clear this screen first. I will log into it, then I'll clear the screen, then I'll become sudo. So I'll clear the screen again. Now, so where I am, pwd, so I am in the root. I will enter into the tmp. Yes, so there are a lot of files here. So I'll create one more file, one more directory, mkdir, and this is Linux security. Linux sec. So cd Linux sec. Okay, that's wrong. Nothing is there. So let me clear the screen, and then let's touch the files here. Touch file and square curly braces 1, 2, 3 and .txt. So now 3. Okay, ls three files has been created: file1.txt, file2.txt, file3.txt, and file type of each one should be yes. Okay, these are .txt files. So now let us check for owner read, write, execute. For group members read only, for others also read only. These are the permissions that are available. Now how will it change? Chmod 760, 7 for the owner, 6 for the group, and 0 for others. So here I want to give all permissions to owner, and read and executable permission to read and write permissions to our group members, and no permission at all, no permission at all for the others. Let's see how can we do that. For that, chmod 760 and then file1.txt. Now we'll do the same thing and check. See the magic. This remains same, this remains same, but file1.txt, just compare this. Here we have file1.txt, and then here we have file1.txt. After changing the permissions, for owner you gave all permissions, for group members you gave only read write permission, no execution permission, and for the others completely zero permissions. This is how you can change the permissions using octal members. So now, instead of using the normal string of 3 sets of 3 characters, the chmod command takes a different approach. The following is the format for specifying a permission in symbolic mode. So you can see this, you can see it on screen. You have 3 sets of characters in 3 square brackets, 3 closed square brackets. First one makes perfectly good sense, doesn't it? So the first group of characters defines to whom the new permissions apply. This first group of character, this part, and then next a symbol is used to indicate whether you want to add the permission to the existing permissions, that's plus, or subtract the permission from the existing permission, that is minus, or set the permissions to the value, that's equal, equal to. And finally the third symbol is the permission used for the setting. You may notice that there are more than the normal RWX values here. These are the additional settings. X assigns the execute permission, and S sets the UID or GID on the execution. T saves the program text. U sets the permission to the owner's permission. G sets the permission to the group's permission. O sets the permission to the other's permission other than RWX. And here you see U for the user, G for the group, O for the others, A for the all of the above. And RWX is anyway common. Other than that, you have additional settings, and plus and minus and equal. Now, using these permissions looks like below. You can see that on the screen. The first example, chmod, the O plus R entry adds the read permission to whatever permission the everyone security level already had. O for others. So add read permission to the others. That's it. Okay. Then the next example will take the u minus x. The u minus x entry removes the execute permissions that the user already had. Note that the minus f option for the ls command indicates whether a file has execution permissions by adding the asterisk to the file name. And so what we'll do is we will test once. Let's get into this. Clear and cd tmp ls. Okay, so we have file1.txt, out of which let me check ls lrt. We'll select one. So kantara lyrics, for example, this one we will take it. Here it doesn't have write and execute permission for the group members as well as others. Now what I want to add is I want to add write executed permission for the others. For that, chmod o plus x and then file name is kantara lyrics. Now let's check ls lrt. Here it is. There is a change. Here it is. It's the x has been added. Here there is no x for the kantara lyrics. No x and x. That's how you can change for specifically. Yeah, anyway, you can remove it also. We will use the same one. Put minus and remove the execute permission, or you remove the read permission. That's it, gone. Here read, here no read, here there is a read permission for the kantara lyrics. Okay, that's what I'm trying to prove here. So we did it. So next, changing the ownership. This is also very important. Sometimes you need to change the owner of a file itself. In that case, what will you do? In such a case, when someone leaves an organization or a developer creates an application that needs to be owned by a system account when it is in production, so Linux provides two commands for doing that. One is the ch1, the most famous one. Ch1 command makes it easy to change the owner of a file, and the ch group command allows you to change the default group of a file. So these are the two examples. For example, if you check, all these files are created by root user only, so there is nothing much to do here. But still, if you want to change the ch1, okay, there is a wrong ch1 and then charan, if it is there, kantara lyrics, I think, yeah, it's got charan. That's it. It's changed. The owner of the file itself is changed. That's how it works. So now we will specifically look into changing permissions in numeric method. So for that we use a 3-digit mode number. It's actually octa that we have discussed earlier. First digit specifies owner's permissions. Second digit specifies group permission. Third digit represents others permissions. So permissions are calculated by adding the numbers. Okay. For the read that we have seen before, only read, and one for write. One for execute and two for write. Now, for example, chmod 640 means for owner give read and write permission, and for the group members give only read, and for others no permission at all. So let's do it. Clear. Okay. Mhm. So ls, I think I am in home. cdtmp. Yeah, there are a lot of files. Let me do lslrt. For example, okay, this one has a read, write, and no execute and this permission. So what I have to do is I want to make chmod 640. So 640, the owner should have only two, that's a read and a write, no execute permission. And then for group members only read, and for others zero permission. So that, then in that case I will select this one, rw. Okay. I think this one would be better, this Jenkins one. So let me check. Clear ch mode 640 and Jenkins. That's okay. That's okay. I will do it. Don't worry. Chmod 640 Jenkins. Where I am? Okay. cdtmp. Clear again. Chmod 640 and Jenkins. ls lrt. Where is Jenkins? Yeah, here it is. Jenkins. Yeah. Read, write, and then only read for the group members and no permission at all for others. That's how you can use the numbers even to change the settings. So now what will we do is, before we close up these permissions slide, let's do a detailed exercise for this. Okay, so let's begin in the same Ubuntu. Here let's change the permissions using letters first, and then we will change the permission using the numbers. So in here in tmp I will create a directory, the parental directory, that's opt, sorry, I devops dir, then enter into that. Okay, so now let me add some groups. Group add iDevOps, and then user add Ansible, user add Jenkins, user add, okay, it's fine, AWS, it's also existed, no, it's not that. So and finally add user, this is a regular user, Rama. Okay, new password, and this one, and after that we will have a room number. So work phone, you can give anything, and the home phone same, and others information, and finally click on Y. Yes, it's done. So now after adding the users and group, So it's time to check the group files so that we can clearly see whether this group has been added to it or not, and similarly these users has been added it or not. So let me do vim to see the file and etc, and then etc and group. Here you can see iDevOps is your group and all of the files are also there, so it's clear. So now you can just get out of this pod itself, and you can, if you want to check, you can cross check it, id ansible. That's it. So now let's do some changes. Let's do some permission changes. So ls ld, okay, now let's create some files. Touch file 1 5.txt, and then let me click on enter. So let me check ls ld. Yeah, now how many files are there? Okay, ls, yeah, we got the files, total 5 files are there. So when I do long listing ls lrt, so we have total 5 files are here, and now I will do the changes one by one. So the first one, chone and capital R recursive, and then ansible attached to the DevOps group, and then DevOps dir. So we haven't added the DevOps group to the Ansible to the DevOps group. That's fine. So now we'll start changing the permissions. So ls lrt, and we'll check each file. For example, I'll get one step behind. So now ls lrt now. So iDevOps, this is the one. Here read write execute permission for all, for owner, and read and execute permission for group members, and read execute permission for the others also, but no write permission for the group members and others. Now what I will do is I want to remove execute permission for the others. I don't want other people other than who are in my group entering or executing anything in my folder. So that's what I want to do. For that, what I have to do is chmod 0 -x, and then iDevOps dir. Now let's check lslrt again. Here it is. It's been removed. Execute permission for others has been removed. So that's how you can take out the permissions, access to the other members who are there in your system. So now I want to remove even the read permission for the other members. So how will I do? Same thing. chmod wo -r, and then iDevOps dir. Let's check it again. Here it is. Even the read permissions are also has been removed for others. So even they cannot read, they cannot write, they cannot execute, they cannot do anything in my directory. So that's how I can limit the access to other members of the other users of the system. to read, write, access my directories. And chmod, let me clear this, chmod, and then group, this is for the group member, add write access to the group members for DevOps dir. Sorry, I DevOps dir. Now let me check it. LRT, yes it is. Yes, you got it. So I gave a write access to the group members whom with I associated. So that's how I can give accesses. I can take out the access to my directories because I am the owner of it. So that's it. So now let's move on to another component, another part of this session, that is changing permissions using numbers. Changing permissions using numbers. Okay, so for that we'll create one more directory, that is mkdir opt and then web data. Just a sample, anything. Okay, so the directory has been created. Now let's check lsld opt web data. Yes, this is the information about that, and these are the permission levels of the web data directory. You can clearly see it's a directory, and the owner has a read, write, execute permission, group members has a read and execute permission, not write permission, and others has a read and execute permission. Now I want to limit these people. So how can I do? So first thing I will do is chmod 7. 7 means read, write, execute permission for the owner, and 7 read, write, execute permission for the group member, and 0 no permission at all for the others who are not part of my group. Sorry. So chmod 770 and then opt web data. This is the directory where I want to do. So let me check it again. Here it is. All access has been removed for the others. For owner, read, write, execution, and for the group members, we have even given the execution, write permission. Here there is no write permission, but after the change we gave the write permission. And whereas for the user, for others they used to be read and execute permission, now we have removed those also. That's how with a simple one line command you can take out or give the permissions. So then we will do a funnier task, chmod. Let's give all zeros and do and see what's going to happen. Let's do, let's take it as per your intuitive. What's going to happen? Boom! All gone. No permissions for owner, no access to the group members, no access to the others also. This is how. Now if you want to bring it back all the permissions, if you want to restore all the permission, again chmod 777 all for all uh, and then opt web data. Let's check it again. Here it is, green. It is for all. Read, write, execute permission for owner. Read, write, execute permission for the group. Read, write, execute permission for others also. We have opened it to everybody. So that's it. You just keep practicing it. It would be very helpful for a that system administrator. Not only that, for ML engineer and ML ops guy also, it's very much pretty much important, this concept. So you just go through it. Now let's put all things together, and we will do a big exercise which is very important for a system administrator. So that's adding a user and then setting a password and switch back and forth from root user to the regular user. So that would be our first activity. Then after that we will go for the again adding user into the group, adding user into the group, then deleting the user and deleting the group. And final one is just using id command to know about the user. And finally, if there is anything, just deleting the user and user group. Oh, that's what we are going to do. These are the activities that we are going to do. Okay, so let's open Ubuntu this time. I will extend it a bit more. So now there are actually three types of users: root, system users, and then regular users. Root users can be added because as a root user only I can do all these activities. So um, I can add either a system users or a processes as a user or a regular user. So we have two types of commands here: user add and then add user. So if you use user add, it will only create a user, a process user. A process user will not have a home address or home directory. For example, we will add user add AWS. I'm adding AWS. As it got added, if you have doubt, you can check AWS. Here it is. UID, user ID for AWS is 1003. This is not a system user. This is a user as a process. And group ID is 1003 and groups is this. But definitely it will not have home address. See, yes, you have a Rama user, Ubuntu. That's it. Only two users. AWS has not been allocated a particular home directory. So that is what I'm saying. This, if you use a user add command, you can create a user only for the process. So similarly, we will add few more: user add Docker and then user add Jenkins. So we got created three users now. These are processes as the users. Now we will create an actual users. So for that we have to use add user command. Add user and then first name would be Charan. Okay. So this is what's going to happen. Adding user Charan, adding new group Charan 1006, adding new user. So now it's asking and creating a home directory for Charan, that is /home and then Charan. So this is the home directory for the Charan. So now password is asking. I'll give the password and I'll retype the password. It's done. Full name it's asking Charan and then room number I take 1004 something 1006, anything you can take. Work phone 73891 and home phone anything again and others anything. And is this information correct? Absolutely. That's it. Your regular user is ready. If you have doubt, you can clearly check. I'll just clear the screen here. Just a minute. Yes. Now cd home. Here it is. Charan. That's what I'm saying. Similarly, we will add few more users. That is add user Divya same password name, room number, anything, work phone, anything, home phone, anything, other, anything, and why. That's it. Alice, Divya is ready. This is the home directory of the user, regular user Divya, and each we are giving password also. And you will add one more user, that is add user Surya. Okay, so password name, room number, and phone number, other, and then y. That's it. Okay. Okay. Yes, done. Surya is also done. So three regular users had been added, and 3 users as process has been added. So now let's verify these users from the file directly from the file. So let me clear the screen first. Yes, it's been cleared. Now let's use a tail, and how many? I want 4. So last etc passwd. Here it is: Jenkins, Charan, Divya, Surya. These are the 4 users that has been added recently. So I'll put 6 because I've added 6 now. So let's look into the 6. See, AWS, Docker, Jenkins, Charan, Divya, Surya. So that's how it works. So if you want to check it, ID and Docker, UID, user ID of Docker, group ID of Docker, groups, and everything. So we have added 6 users, 3 are regular users, and 3 are user as a process. So now let me clear the screen. So now one more activity I have to do here is switching back and forth from user to, because for all I have added the password, but still if I want to change the password I can change, but before that I'll switch back and forth. So now I'm a root user. I want to become Surya. Just type Surya. So I became a Surya. So now from here I want to become Charan. So you can see who, that's Ubuntu. Who, okay. Who am I? Surya. Okay. So now I'll switch to Charan. It's asking password. That's it. Who am I? This is Charan, bro. Here it is. That's how you switch from one user to user and back to sudo. So then I will switch to Divya, and password is Divya, and who am I? This is Divya. Okay, and from here even you can switch to AWS. Password I did not give, I do not have, so I can't switch. Okay, let me clear the screen first. Let's set up the password for those. Passwd AWS. You may not view or modify password. Okay, got it. First let me become a sudo password. Okay. This is one more issue. Okay, I'll become Ubuntu at least. Hi, Ubuntu password is also not there. Okay, here I'm facing one issue. when I want to switch from sudo from normal user to root user, it's saying this user is not in the sudoers file. So how I now at this moment I can't handle because I have to do some other things. So I will solve this issue, uh, because but you note it down why we are unable to become a sudo, or we are unable to become a root user because of we are not in the sudoers file. So once we add ours into the sudoers file, then we can become a root user. Okay, so that we will do in a later session, but for now let's close it. I'll Yeah, let me get it. Yeah, now I came to root user. So now I will add passwd for AWS. So I'll give password for AWS, and AWS password is password do not match. Okay, that's fine. So I'll give passwords one more time. AWS. Yes, we have added a password for AWS, and similarly we will add password for Docker also. Passwd for Docker. That's a Docker. That's a Docker. So even we have added the password for Docker too, and passwd for Jenkins. 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 Oh, that's fine. Let me do it one more time. Jenkins. Yes, this time it's done. So we successfully attached a password for AWS, Docker, and Jenkins. Anyway, other three users anyway have the passwords with them. Okay, so now let's try to switch back and forth from root user to AWS, root user to Charan. Yeah, from Charan to AWS. It's asking password. I'll give the password now. Okay. Then clear. Yes, I'm in AWS user. So let me exit back to Charan, and then again we'll do that. So Charan, so AWS password AWS, and who am I? This is AWS. That's what I'm saying. So there are two types of users again. In the regular user, one will have all access with the home directory. Other one is like a process. It will not have a home directory. So AWS is that kind, and then Charan is of a regular user with the home directory. Okay. So now, so it's time. So we added user, we set password, when we switch to user, all done. So now it's time to add into the group. Before deleting, it's time these things to be added into the group. So for that, what I will do is I'll take the same one, but before that let me come out, exit and exit. So I am as a root user now. So let me clear the screen first, and now I will create a group. I'll create a group name as iDevOps for you. This is the group I have to create. So I'll create that group, and I will add all these users into that group. Group command. Group add is the command which we use to create a group, and group name is iDevOps for you. Okay, so your group has been created. If you have doubt, you can check it. So now what we have to do is to add all these groups, all these users into this group. Either we can do it in a two different way. Either you open the group file and add the names directly there, or in another way, use a command, the user mod command. User mod command, and then A option and capital G option, and group name is iDevOps for you, and user you want to add is AWS. That's it. It's been added. If you want to check ID AWS, here it is. Group ID is this, and 1009. This is what the group ID iDevOps for you. It's been added for that. Now you can do the same for other groups also. That's Docker, and then other one is Jenkins. Let's check the group file now. Okay, let's clear the session, and cat etc and group. Yes, here it is. iDevOps for you with the group ID 1009 and consists of 3 users has been attached with this group. That's AWS, Docker, and Jenkins. Now I will show you a second method. Here, to add a group, to add a user to this group, the other method is okay, got it. So I'll do vim and etc group. Yep. So here it is. I'll find that iDevOps group. It is at the bottommost. iDevOps for you is the group 1009. I will add other users directly. Okay. Charan and Surya. And let me click escape and then save it and quit it. Yes. So let me clear the screen, and then now I will check ID Charan. Team 1009 iDevOps for you. That's it. It's been added to that group. And similarly, I will check for ID Surya. Here it is. Team 1009 iDevOps for you. It's been added for this group also. This is how you do it, either using a command or directly writing and adding a user name into the group file. So I'll do the same again. This time I will use command to add it to the group, but this time the user name is Divya. Yes, it's done. ID Divya. That's it. See, it's been added. iDevOps for you. So that's how we add groups. So now let's look into deleting user and deleting groups. How do you delete the users and how do you delete the groups? For that, again, we'll get back to our space. Let me clear the screen first, and then let's check how many users are there. Regular users. So Charan, Divya, Rama user, Surya. Ubuntu is basic. So by default, it has come up with distribution when we install it. So to delete, I have to use user del, and then r recursive, whatever is there in that, and then Jenkins is the one. Of course, I will delete Surya first from here instead of Jenkins. Let's see. Okay, Surya mail spool not found. That's fine. That's it. It's been deleted. Here it is. Surya is gone. Now you can delete the AWS account also. User del, sorry, not AWS account, the AWS user also. User del or AWS. So of course they do not have even directory because that's a different way of creation. Okay, so let me check AWS. No such user, so that also has been deleted. Okay, and then now, is it possible to delete the group? Yes, it is possible to delete the group. For that we have to use group del and I DevOps for you. That's it. The group has been deleted. If you have doubt, you can check it. Cat etc group gone, gone. There is no DevOps for you. Let me clear the screen again. So that's it. That's how you create and you delete the groups, users, and all the information one by one. Okay. So this the final part. Anyway, deletion of user and deletion of group, we have done it, and id command also we have used it so many times, but still I'll show one more time. Id Charan. See, when you use id and then username, it will give the information about that user. Is uid, is gid, and which group is part of, and everything will be shown there. Okay. So now, Charan, who am I? Charan is the user, so a regular user. So now he wants to do the sudoing. Let's see, is it possible to do sudoing? Sudoing, sorry, that's my mistake. SUDOI, sudo. So it's asking password. It's CHARAN Charan, but what it is saying, Charan is not in the sudoers file. So this incident will reported. It will be reported to the root user. That's fine. But I am unable to do the sudoing. So if I am not able to do the sudoing, if I can't uh, become a sudoer or sudo, then I cannot do lot of activities in this system. So how can I do that? How can I solve this issue? So that's what we are going to look into now. So that's a Linux setting sudo. So sudo, what is sudo first? Sudo gives power to a normal user or a regular user to execute commands which is owned by the root user. It's like the binary files or admin level binary files that are can only be executed by the root user. So when you use a sudo, if you become a sudoer, you can have that privileges to use those binary files also, like the commands. Few commands which cannot be used by the regular user can only be used by the root user, can also be used by the regular user if you use a sudo. So now if a user has already full sudoers privilege, it can become a root user anytime. But sometimes, like happened to us just a while ago, we faced the same challenge. Sudo I changes from normal user to root user, but what happened for us, it did not happen because we are not in the sudoers list. So now let us see what is that sudoer list, where it is. So the sudoer list, what we can do is, let's clear this first, then I'll type vi sudo. Of course I'm a root user, so let me exit first. I'm not a root user, let me exit first. Okay, I'm a root user now. Now vi sudo. So this is the file where you will have a root sudoers. So now if you see, user privilege specification is only for root user, so no regular user is being mentioned here. So that means you cannot do anything with this. So exit. So now I just, okay, so this is our sudoers file. You can get it. So if you want to do any modifications, if you want to add a regular user as a sudoer, so what you have to do is you have to just add that a regular username below the root user, so that he can become a sudoer. He can become a sudoer. Okay, so then what we have is, so let's do it. Oh, just, oh, I mistake, I closed it. And yeah, so let me clear this. Vs sudo and ps. Okay, all are stopped. Let me clear it. So that's how either you can use vs sudo to directly get that file, or another way of accessing that is do vim and etc, and the file name is sudoers. Yes, it is. You got it. So now we can edit it and you can add it, but before that let's look into that. So this is how you got it. You got the file. So now whichever user you want to make a sudoer, you just add that sudoers, add that name into that sudoers list. Okay, let's do that now. So this is the place where I want to add the sudoers name. Yes, press enter to type command. Now where is this? Yeah, here it is. Let me copy this exactly and only change the name later. Copy and then paste it here. Yes, it's done. Then change the name. Rest all keep it same. Just change the name. That's it. Okay. Let's WQ. Okay. WQ. Yes, it's done. So now let's try it and check. So Charan was the user which we have added into sudoers. Let's check it. So Charan. So a regular user. Who am I? Is a regular user. Now I will become a sudoer and let's see. I want to become. It's asking password. I'll give the password. Yes, it's done. That's how you add a regular user into sudo file, so that you can take that privileges to act on behalf of root user and use a lot of utilities that you cannot, a normal user can use. Okay, so then we will move on to the second way of doing this procedure, every time you enter sudo command, it asks your own password. So what can you do that? So to turn that off, so if you don't want to enter a password whenever you switching back and forth from a sudo root user and then a regular user, it asks a password. If you don't want that to happen, if you don't want to give password every time, still you can do that. That you have to do in a following way. For that, it's simple. Same again, go back to the root, go back to the file again, the same sudoers file. Let me go up. Okay, here I can see I'm a root user still. Vim etc sudoers. Yes, I got it. I got the file. So in this file, what you have to do is all equals to all. Change this to here at this part exactly. No password all. So you keep this one remain same, but here you put one more colon and then say no password all. So that's what we are going to do. Let me click I, and where it is, it's here it is. So let me type no pass wd, no pass wd, and then colon, capital no pass wd, and then colon. I think it's done. Let me click escape and wq. Okay, so let me clear everything and I'll become Charan. I'll switch to Charan user, and then who am I? It's Charan. Now I'll become a root user again and see sudo I. No password. Ting ting ting. It's not asking password. So that's how you do it. You can do it for the other users also. Let me check. I have Surya, right? No, Divya. I have Divya. So ID Divya. Okay, I have Divya, but Divya can't. I'll switch to from root to. I'll switch to Divya. Divya. Oh, sorry, Divya. Yes, I become a Divya user now. So I say ID. Okay, who am I? It's clearly Divya, the user. So now what I'll do is I'll try to switch back to root user using sudo I, but it's asking password. I'll give the password. Divya is not in the sudo file. So what you have to do? You have to do the same thing again. So let me do the exit. I'm the root user now. So now I will edit the sudoers file again. I will add this time Divya there. Where is that? Here it is. So I'll copy this one again and I will add that here. Yes, and my username is Divya at this moment. So I will give Divya. Anyway, the password we set in such a way that it should not ask password. So all done. Let me click escape, WQ and exclamation mark to forcibly quit it. Done. Now let's see what's gonna happen. SU Divya and sudo I. That's it. Ting ting ting. That's how we use these techniques to create more users and give permissions and create passwords and switch back and forth. And these are a lot of techniques. These are widely used by the system administrators, but as a ML engineer, as a ML ops guy, if you know all these information, all these techniques, all these commands, it would be very beneficial for your career. So this section, the previous session discussed, in this session we have discussed the command line commands that you need to know to manage the Linux security on your system. And Linux uses a system of user IDs and group IDs to protect access to files, directories, and devices. So Linux stores information about user accounts in the etc passwd file and information about groups in the etc group file. So each user is assigned a unique numeric user ID along with a text login name to identify the users in the system. So groups are also assigned unique numerical group IDs and text group names. A group can contain one or more users to allow shared access to the system resources. And in addition to that, we used chmod command to change security settings for files and directories. Only the file's owner can change permissions for a file or a directory. However, the root user can change the security settings for any file or directory on the system. You can use the chown or and the chgrp commands to change the default owner and group of the file. So now let's jump into the concept of installing software. So in the good old days of Linux, installing software could be a painful experience. Fortunately, the Linux developers have made life a little easier for us by bundling software into pre-built packages that are much easier to install. However, you still have a little work to do to get the software packages installed, especially if you want to do that from the command line. So package management primer, that's what we call as a package management primer, PMP. So each of the major Linux distributions utilizes some form of the package management system, PMS, to control installing software applications and libraries. A PMS utilizes a database that keeps track of these items. What are those? First one, what software packages are installed on the Linux system and what files have been installed for each package and versions of each of the software packages installed. So now, so the software packages are stored on servers. So these servers are called as repositories, and these repositories are accessed across the internet via PMS utilities running on your local Linux system. So we'll see what is PMS utility. Okay, so now you can use PMS utilities and their utilities to search for new software packages or even updates to software packages already installed on the system. Now, a software package often has dependencies or other packages that must be installed first for the software to run properly. So the PMS utilities automatically detect these dependencies and offer to install any additionally needed software packages before installing the desired package. But the big downside of PMS is that there isn't a single standard utility, whereas all the bash shell commands discussed so far in this book, so far in this course, work no matter which Linux distribution you use. This is not true with the software package management. So PMS, that's a package management system. So here the PMS utilities and their associated commands are vastly different between the various Linux distributions. The two primary PMS based utilities commonly used in the Linux world are known as dpkg and RPM. So dpkg is Ubuntu Debian based. RPM is M. It's other one is okay. So the Debian based distributions such as Ubuntu and Ubuntu, Linux Mint, and Debian use this at the base of their PMS utilities, the dpkg command. So this command interacts directly with the PMS on the Linux system and is used for installing, managing, and removing software packages. On the other side, we have the Red Hat Enterprise Limited and Red Hat based distributions such as Fedora, OpenSUSE, and Mandriva, CentOS use the RPM based. These are called RPM command at the base of their PMS, similar to the dpkg command. The RPM command can list installed packages again and install new packages and remove existing software. So in this, the dpkg package, the dpkg commands is at the core of the Debian based family of PMS tools. So these other tools are included in this PMS. So apt-get is one PMS tool, apt-cache is another PMS tool, aptitude is the another PMS tool. By far the most common command line tool is aptitude, and for a good reason. The aptitude tool is essentially a front end for both the apt tools and dpkg, whereas dpkg is a PMS tool. Aptitude is a complete package management system, PMS. So using the aptitude command at the command line helps you avoid software installation problems such as missing software dependencies, unstable system environments, and just a lot of unnecessary hassle. So this section looks at how to use the aptitude command tool from the Linux command line. On other side, in RPM side, like the Debian based distributions, the Red Hat based systems have several different front end tools that are available. These are the common ones are M for M for Red Hat and Fedora, and URPM for Mandriva, and Jipper for OpenSUSE. So these front ends are all based on the RPM command line tool. The following section discusses how to manage software packages using the various RPM based tools. The focus is on M, but information is also included for the Jipper and URPM. So now let's begin with the managing packages for Debian based. A common task faced by Linux system administrators is to determine what packages are already installed on the system. So fortunately, Aptitude has a handy interactive interface that makes this task an easy one. So let's log into the Ubuntu first. So by the time our Ubuntu gets ready, so let's get into here git bash and go back to the instances. Is it just a minute? Yeah, CentOS. Yep, it's ready. So both are ready, CentOS as well as Ubuntu. So initially let's begin with the Ubuntu package management. So let me become sudo. Yes. So now if you have just type aptitude and press enter. Let's see what's going to happen. App, yeah, complete information about that aptitude. Oh, of course it doesn't have aptitude. We have to install aptitude also in this app It has apt1, apt and then apt-get, apt-cache. So aptitude show package name, the second one. I'll use the similar one. Oh, okay, this is CentOS. Apt show package. In spite of installing, unable to locate package. Okay. Sorry, that's my mistake. I have to apt show any package name, httpd. So there is no such package exist in this. And on other side, yum for the CentOS. Yes, it's loading. It will give you a list of all the packages which are installed. Here you can see all the list, complete list of it. Then after that we will go for installing the packages. How to do that? Okay, for aptitude, I don't think I do not have aptitude here, so I have to install. Okay, let me try aptitude. Apt install. Now let us we can use this. Well, let me clear this first. So aptitude, it's loading, it's building. Yeah, upgradable packages are 2, installed packages are 625, not installed packages. You got the complete information. So let's get back to this and let's clear it. So aptitude show, aptitude search. If you use aptitude and search any package name, httpd. So let's see. We got light httpd mode, micro httpd, might httpd2, mini httpd2, mini httpd run. So a lot of packages it's showing. Now let's run another package, that's Apache 2. Apache 2. It's running. Okay. So RT4 Apache 2. So it has in that aptitude database, it has a lot of packages which are really close to the Apache 2. All those were shown. So now to install, so what you have to do, how to proceed to install a package using a aptitude. So as here I'm in, I just want to, yeah, I'll clear the screen, and I'm a root user. I want to be in Ubuntu. This is, yeah, here it is. Yeah, Ubuntu. Now what I'll do is, as I'm a root user, I don't need to use sudo, so I will say aptitude and then install Apache 2. Anything you can install, just install Apache 2. Yeah, Apache 2 is getting installed. Do you want to continue the installation? Yes, of course I do. Yes. So now installation of Apache 2 is going on. Once it is done, we'll get to know. On other side, if you want to do the same thing, you can use in CentOS M provides package name.rpm. Then if you want to install, so that's how you have to install. Okay, let's get into the CentOS. CentOS is here. So yum and provides, okay, httpd. That's it. See, these many httpd versions are available for your CentOS. It's pretty nice. Now I want to install yum install httpd. Say httpd or Apache 2. These two are, you need to reboot. You need to, okay, that's fine. Sudo either httpd is the service which we use to host a static website for Ubuntu for CentOS, and Apache 2 is a service which is used to host a static website for Ubuntu, and HTTPD is for the CentOS. Okay, so now let's install yum install httpd, because httpd is a service which is used to host a static web application for the CentOS. So that's the reason we are installing httpd service in this. Package httpd version installed. Okay, httpd installation is done. So let's check system ctl status httpd service. Yep, it's there. It's dead, of course, but it's disabled, but it's installed. Similarly, let's check for the Ubuntu whether it got installed or not. For Ubuntu, is it done? Apache 2. So system ctl status Apache 2. Yes, it's done, it's running. So the both the packages got installed, Apache 2 and CentOS for RPM based, HTTPD for RPM based CentOS, and then Apache 2 for the DPKG based Ubuntu. Now, how do you update the software? To update the software, we'll use aptitude safe upgrade or aptitude full upgrade. Let's do it. So this is our Ubuntu. So let me do it. Okay, yep, let me clear it. Let me clear the screen. So aptitude safe upgrade. Of course, it may take a lot of time, but that's okay. Why? Let's upgrade it as quickly as possible. Then I don't need to go for the full upgrade. It will take some few more times. And distribution upgrade for CentOS. This is the way. Let me clear the screen first. Yum and list updates. So it has listed all the updates. Now you mentioned the package which you want to update, so I will update. I'll go for the update of yum update httpd. Yes, no package marked for the update. That got updated completely. And just give a random update, so that will update your package itself. Yum update. That's it. Then we will move on to installing software. So we have installed two softwares. One is in Ubuntu, one is in CentOS. Let's look into an installation procedure in Ubuntu first. So in Ubuntu, aptitude remove package name for just normal removal. If you give aptitude purge and then package name, it will remove even the folders which are related to that. So let's do the purge. Let's go for the purge. Here it is, our Ubuntu. So yeah, it's fine. Now what will we do is aptitude purge and Apache 2. Let's see. It's Y. Yes, uninstall it. Continue with the uninstallation procedure. It's no issue at all. Meanwhile, yeah, it's done. Let me check. What's the status of that? Systemctl status Apache 2. Yes, it's gone. Apache 2 service could not be found. That means it's gone. It got completely purged out of the system. So now let's check for the RPM based. How do you do that? Yum remove or m erase. Let's use erase. It will completely erase the packages also. So here it is. I think it's upgrading. Still it's upgrading. We have clicked update now. Let's close it in between. Let's clear the session and yum erase and then httpd. That's what we have installed. Let's remove it completely. It's taking some time. Yes, I want to remove it. Yes, it's done. Let's check it. Systemctl status and then httpd. Yes, httpd.service could not be found. That's it. It's gone. This is how you use a package management software for installation, updation, uninstallation, removing, purging, and everything. Then we will move on to the next stage. So here, what will we do is the aptitude repositories. So the default, what is the aptitude repository? We have seen that we have few repositories, the aptitude repository, M repositories. So what is the difference between them? The aptitude repository, this is the default software repository locations for aptitude and which are set up for you when you install your Linux distribution. The repository locations are stored in the below file. I'll show it to you. Okay. Just a minute. There one. Yeah. This is our Apache. This is our Ubuntu. Let me clear the screen. Now, let me cat etc apt and then sources dot list. So it's huge. These are the locations from where these are the repositories from where this will go and get the softwares for us. You can see that http us east 1 ec2.archive ubuntu.com focal updates. There is a lot of http security for each application, each utility. There will be a different resource. These are the resources list for Ubuntu. Similarly, we can view for the yum repositories also. For m, what we have to do is just type yum repo list. Yum repo list. Yes, you got it. There is a huge repo list for the m too. But this is information if you just want to explore it. It's not that important to know. Okay. These are the M repo. That's what the aptitude repositories. We have seen both. So now install. This is one way directly using from the repositories, or the another way is installing source code. Installing directly from the source code. Then how will you do? So if you work in the open source software environment much, so there is a good chance you will still find software packed up as a tarball. That's where the tarball comes into the picture. So what you have to do is you have to go to their website and you download the tarball from their system, and then you or directly you take the link of that and you download the tarball into our Linux system using wget. And then once you get it, you use a tar and then option zxvf and then that file name. So that will untar the file and you will get the binary file. So you place the binary file in the proper area, proper directory, so that you can start using that application. That's how uh, we do that's how we install tools also. So that's the last way of installing the tools. uh, so now finally, just before we closing up these things, I think we have covered most of the things in this purging, from installation, management and updation, and then purging. I think it's more than enough. Anyway, this tar, using the tarball, in future we are going to deploy few applications, and then we are going to run that application in the server and access through the internet. So while we do that, at that time, anyway we'll be working on the tar. So I think for now it's more than enough from this point of view. In previous session, we have discussed how to work with the package management systems, that's PMS, uh, to install, update, or remove software from the command line. Although most of the Linux distributions use fancy graphical user interface tools for software package management, you can also perform package management from the command line. And the Debian based Linux distributions use the dpkg utility to interface with the PMS from the command line. A front end to the dpkg utility is aptitude. It provides simple command line options for working with software packages in the dpkg format. On other side, the Red Hat based Linux distributions are based on the RPM utility but use the different front-end tools at the command line. So Red Hat and Fedora use MYUM for installing and managing software packages. The OpenSUSE distribution uses Jipper for managing software, while Mandriva distribution uses URPM. So finally, so now this session closed with a discussion on how to install software packages that are only distributed in source code tarballs. The tar command allows you to unpack the source code files from the tarball and configure and make allow you to build the final executable program from the source code. In addition to that, we have seen few exercises also in the previous session. So now we'll be moving on to the a new session, that is working with editors. So before you begin your exploration of the Vim editor, it's a good idea to understand what Vim package your Linux system has installed. On some distributions you will have the full Vim package installed and an alias for the vi command as shown on the CentOS distributions. So checking your Vim package, for that we have to use which Vim. So the basic Vim editor is now installed on this Ubuntu distribution, and the user bin va program files link was automatically changed to point to user bin vim basic. So thus when the vi command is entered on this Ubuntu system, the basic Vim editor is used instead of tiny Vim. So let's clear which Vim it is. A user bin Vim, that's what. And so if you do not have a Vim in it, then what you have to do is you have to install, for example, let's take this is our CentOS, which, sorry, just a minute, yeah, which Vim, yeah, it doesn't have a Vim, user bin which no Vim. So as it doesn't have a Vim, so what we can do is we can install. For that sudo is not required, yum install Vim. It's installing. Meanwhile Ubuntu comes up with one Vim, whereas uh, whereas CentOS doesn't come with Vim. So then in that case you have to install Vim. So meanwhile the installation process takes place. Let's move on to the another thing. So next topic. So now exploring, let's begin with the exploration of basics of Vim. So if you want to write any file, how do you do that? So you have to use vim command and then use the name of the file. Then automatically it will take into that file. So all the vim is very complicated editor with many powerful features. And there is one more editor that nano is also widely used in it. So nano is a very simple editor. Okay, so now Vim as Vim editor has two modes of operation. One is normal mode and second one is insert mode. So we'll see what is normal mode and insert mode while we are doing while we are working practically on the Vim. So what is a normal mode in theoretically? So when you first open a file or start a new file, either opening an existing file or starting a new file for editing, the Vim editor enters a normal mode. So in normal mode, the Vim editor interprets keystrokes as commands. More on those. So in insert mode, then when you press I key, then it will be turned into insert mode. So Vim inserts every key you type at the current cursor location in the buffer. So this is called an insert mode. So to get out of the insert mode and go back into normal mode, press escape key on the keyboard. That we will do it in a second's later. So within the command line mode are several commands for saving the buffer to the file in existing Vim. So Q to quit if no changes have been made to the buffer data, and Q exclamation mark to quit, discard any changes made to the buffer data, and W file name to save the file under a different file name, and WQ is to save buffer data to the file and quit it, and press escape to switch over to the normal mode, and press shift plus Z two times to take us back to the terminal interface. So let's get to this clear. We are in ls. There are a lot of files. Let me edit existing file, that is vim code.py. So here we have some code. So now as soon as you execute the command vim, so it opens up vim editor. So now it is completely normal mode. So you can move across, you type whatever you type, it doesn't take. Okay, so that's the reason it's in normal mode. Now if you want to do some editing, if you want to add some buffer data to that, then press I. So then it is gone into insert mode. So now it is time to enter data. So this is done. So now we will add a few more sentences. A for loop, you can add a for loop or while loop, or just we'll add a comment, just a comment, uh, additional comment. Okay, and commenting for test. Okay, so that's done. Let's escape, and then now we have many options. When you click on escape, it will take back to the normal mode. When you click on shift plus colon, it will take you to the edit mode. So in this edit mode, if you give W, it will save it. Again, if you give Q, it will quit it. If you give Q and exclamation mark, it will forcibly quit it. I'll give Q, it's been quitted. So that's how you can edit the existing file. Whereas if you want to create a new file, vim html, vim and index.html. So it's in normal mode. Click I. It is in insert mode. Now you can put some HTML tags. any HTML tag you can put, and then after putting HTML tag, and more information, now you can press escape and shift Z and shift Z to close it. That's a one way. Or simply go to the extended edit mode by clicking on shift plus colon and then say WQ to save and quit. This is another way of doing. So in this way you can uh, use your Vim effectively to edit the files and add data into the files in Linux. I use Vim widely in my work life. And we have other editors such as Nano Editor, and then for Nano Editor we use a nanos command, and then myfile.txt, Emacs Editor, Emacs myfile.txt, Genome Editor, and KDE family of editors. So these are many other different editors. For although Vim is very complicated editor with many powerful features, so we have one more editor that's called Nano. Nano is a very simple editor for individuals who need a simple console mode text editor that is easy to navigate around. So Nano is the tool to use. Then we have Emacs. The Emacs editor is an extremely powerful editor that appeared before even Unix was around. So developers liked it so much that they ported it to the Unix environment, and now it is being ported to the Linux environment also. So the Emacs editor started out life as a console editor, much like VI, but it has migrated to the graphical world too. Fantastic, very good journey. Then what we have is if you're working on a Linux system using the Genome editor, Genome or Unity desktop such as Ubuntu environment, there is a graphical text editor that you can use as well. That is gedit text editor. This is for the one who use graphical user interfaces. It's not for our DevOps guys. Then finally we have KDE family of editors. So there are a couple more of editors we have. So in this session, we have taken up a few more things. There are a lot of things we have covered up. We have covered up the exercise on Vim package and how to install the Vim and how to access the Vim and how to use the Vim to create a new file and edit the existing file. And we have looked into the few more editors that are available in Linux.